I imagine a quiet room where candlelight flickers against stone walls, and the air itself seems to hold its breath in anticipation of discovery. There is something about the stillness of evening, when the world outside grows dim, that makes certain thoughts feel closer, more tangible, as though ideas themselves were living things that drift through the shadows. Tonight, I find myself thinking about numbers, not as cold abstractions or mechanical tools, but as doorways into something vast and beautiful, something that has captivated human minds for thousands of years. I picture ancient courtyards where geometric patterns trace themselves across mosaic floors, each tile placed with careful precision, each angle measured with reverence. And I wonder about the hands that first understood these relationships, the minds that first glimpsed the hidden order beneath the chaos of existence. There is a particular quality to mathematical thought, a kind of luminous clarity that seems to exist outside of time itself, as though certain truths were waiting, patient and eternal, for the right person to notice them, to bring them gently into the light. I think of scholars bent over parchment in lamp-lit rooms, tracing figures with careful fingers, their minds reaching towards something just beyond ordinary perception, something that required not just intelligence, but a peculiar kind of courage, the courage to believe that the universe could be understood, that patterns could be found, that meaning could be extracted from the seemingly random dance of phenomena. The story of mathematics is not merely a chronicle of theorems and proofs, though these are certainly part of it. Rather, it is a story of human beings, of individuals who looked at the world and saw questions where others saw only facts, who felt compelled to dig deeper, to push further, to ask why and how with an intensity that bordered on obsession. I imagine walking through a garden at twilight, where the shadows grow long and soft, and in this quiet space I begin to see them, these figures from across the centuries, not as names in textbooks, but as people with hopes and frustrations, with moments of blinding insight and long periods of patient struggle. There is something almost dreamlike about the way mathematical understanding has accumulated over time, each generation building upon the work of those who came before, each breakthrough opening new territories of thought, new landscapes to explore, like travelers adding their own observations to an ever-expanding map of reality. I think about the ancient world, about civilizations that rose and fell while leaving behind traces of their mathematical wisdom, etched in stone, preserved on clay tablets, copied and recopied by scribes who might not have fully understood what they were preserving, but who sensed its importance nonetheless. The Mediterranean light has a particular quality in my imagination, golden and clear, falling across the white columns of temples, illuminating the agora where philosophers gathered to debate, where questions about the nature of reality were not idle speculation, but matters of profound significance. I picture the rivers, the Nile, the Tigris, the Euphrates, their seasonal floods creating practical problems that demanded mathematical solutions, how to measure land, how to calculate volumes, how to predict the movements of the heavens, necessity and curiosity intertwining, each feeding the other. There is a rhythm to this story, a slow unfolding, like watching stars emerge as the sky darkens, one by one, then in clusters, until the whole vault of heaven is alive with light. And so, as the evening deepens around this imagined room, as the candle burns lower and the shadows lengthen. I prepare to follow this thread backward through time, to trace the lineage of those remarkable minds who saw numbers not as servants of commerce alone, but as keys to unlocking the fundamental architecture of existence itself. The journey begins, not with a single moment, but with a gradual awakening, a slow recognition that would ripple across continents and centuries, transforming not just how humans calculated, but how they perceived the very fabric of reality. The earliest mathematical minds emerged from necessity, from the practical demands of civilization itself, where the flooding of rivers required measurement, where the construction of monuments demanded precision, where the movements of celestial bodies needed tracking for the planting and harvesting of crops. In the land between two rivers, in Mesopotamia, scribes sat in temple courtyards under the burning sun, pressing wedge-shaped marks into soft clay tablets, creating what would become humanity's first mathematical texts. These were not abstractions for their own sake, but records of trade, accounts of grain stores, calculations of field areas. Yet within these practical notations, something more profound was stirring. The Babylonians, working in the cities of Ur and Babylon, developed a sophisticated number system based on 60, a choice that still echoes through our world today in the 60 seconds of a minute, the 60 minutes of an hour, the 360 degrees of a circle. They could solve problems that would seem remarkably advanced, finding solutions to what we would now call quadratic equations, though they approached these challenges without the symbolic notation that would come thousands of years later. I imagine these scribes, their fingers stained with clay, learning their craft through repetition and apprenticeship, copying problem after problem, absorbing patterns, developing an intuition for numerical relationships that went beyond mere memorization. They created tables, vast catalogs of reciprocals and multiples, square roots and cube roots, transforming difficult calculations into exercises in looking up and combining known values across the desert, along the fertile banks of the Nile. Another civilization was developing its own mathematical tradition, the Egyptians, builders of monuments that still inspire wonder, approached numbers with a practical elegance all their own. The pyramids stand as testament to their geometric understanding, each massive stone cut and placed with extraordinary precision, the angles calculated to create structures that would endure for millennia. But beyond these monuments, there existed a sophisticated mathematical culture captured in papyrus scrolls, fragile documents that somehow survived the ravages of time. The Rhind mathematical papyrus, named for the Scottish antiquarian who acquired it, but copied by a scribe named Amos around 1650 years before the Common Era, contains 84 problems, each one a window into how the ancient Egyptians thought about numbers and relationships, how they divided bread, how they calculated the volume of granaries, how they worked with fractions in ways that seem almost alien to modern minds. The Egyptians represented fractions almost exclusively as unit fractions, parts written as 1 over some number. So instead of thinking of 2/5 as a single entity, they would express it as 1/3 plus 1/15. This approach, while seemingly cumbersome to contemporary eyes, reflected a deep understanding of numerical relationships, a different way of seeing the world of quantity. I think of Ahmes sitting with his reed brush and black and red ink, carefully copying these problems from an even older text. Now lost to history, he was preserving knowledge, yes, but also participating in a tradition, a lineage of understanding that stretched backward beyond his own time and would reach forward to ours. Both the Babylonians and Egyptians understood the relationship that would later be called the Pythagorean theorem, the connection between the sides of a right triangle, centuries before Pythagoras himself walked the earth. They used this knowledge practically in construction and surveying, perhaps without formulating it as an abstract principle, but recognizing its truth nonetheless. Then, in the Mediterranean world, as Greek civilization flowered, mathematics began to transform into something new, something that sought not just practical solutions, but eternal truths, universal principles that existed independent of their applications. Thales of Miletus, who lived around 600 years before the Common Era, is sometimes called the first true mathematician, though he was also a philosopher, an astronomer, a statesman. He traveled to Egypt, absorbing the mathematical knowledge preserved there, but he brought something new to these ideas, the notion of proof, of demonstrating why something must be true, not just observing that it appears to be so. I picture Thales standing on the shore, watching ships appear over the horizon, using this observation to deduce that the earth must be curved. Applying geometric reasoning to the evidence of his senses, he supposedly calculated the height of pyramids by measuring their shadows, understanding the relationship between similar triangles, seeing pattern and proportion in the world around him. But it was Pythagoras, born on the island of Samos around 570 years before the Common Era, who would transform mathematics into something approaching a religion, a path to understanding the divine order of the cosmos. Pythagoras traveled widely to Egypt, to Babylonia, absorbing the mathematical traditions of these ancient cultures. But when he returned and established his school in Croton, in what is now southern Italy, he created something unprecedented, a community devoted to the study of mathematics as a spiritual discipline. The Pythagoreans, as his followers were called, believed that number was the fundamental reality, that everything in existence could be understood through numerical relationships. They found these relationships everywhere, in the harmonies of music, where they discovered that pleasing intervals corresponded to simple ratios, in the movements of celestial bodies, in the proportions of the human form. I imagine their meetings held in secrecy, where mathematical discoveries were treated as sacred mysteries, where members swore oaths not to reveal certain teachings to outsiders, where the act of understanding geometry was simultaneously an act of approaching the divine. The Pythagorean theorem, the relationship between the sides of a right triangle, became their most famous contribution, though, as we have seen, this relationship was known earlier. What the Pythagoreans did was prove it, demonstrate its necessity, show that it could not be otherwise, and in doing so, they established mathematics as a deductive science built on axioms and logical reasoning. But the Pythagorean worldview, beautiful as it was, contained within it the seeds of a crisis, a discovery so disturbing that legend says the Pythagoreans tried to suppress it, to keep it secret, because it threatened the very foundation of their beliefs. The problem arose when considering the diagonal of a square. If the sides of a square have length 1, then by the Pythagorean theorem, the diagonal must have a length whose square equals 2, but no matter how hard they searched, the Pythagoreans could not find a ratio of whole numbers, a fraction, that when multiplied by itself would equal exactly 2. The discovery of irrational numbers, of quantities that could not be expressed as the ratio of integers, shook the Pythagorean faith in the primacy of whole numbers. Here was something geometrically real, the diagonal of a square that could not be captured by their numerical system. It suggested that geometry might be more fundamental than arithmetic, that continuous magnitude might not reduce to discrete counting. I think of the mathematician, perhaps Hippasus, whose name is attached to this discovery, reportedly revealing this troubling truth to outsiders. Legend says he was drowned for this transgression, whether as punishment or simply lost at sea. The story itself, true or not, reveals how deeply this crisis cut, how threatening this knowledge seemed to those who had built their entire philosophy on the primacy of rational number. Meanwhile, in Athens, mathematics was becoming intertwined with philosophy in new ways. Plato, born around 428 years before the Common Era, placed mathematics at the center of his educational program, above the entrance to his academy. He supposedly inscribed the words, "Let no one ignorant of geometry enter here." For Plato, mathematics was a bridge between the physical world of a changing phenomena and the eternal realm of perfect forms. A triangle drawn in sand might be imperfect, its lines slightly crooked, its angles not quite precise, but the ideal triangle, existing in the realm of forms, was perfect and unchanging, and through mathematical reasoning, through geometry, humans could apprehend these eternal truths. I picture the academy, students gathering in the grove of Academus, discussing philosophy and mathematics in the dappled shade, drawing geometric figures in the dust, debating the nature of knowledge and reality. Mathematics was not merely a tool, but a way of training the mind, of learning to think about the eternal rather than the temporary. Among Plato's students and associates, several names shine through the centuries. Theaetetus, who worked on irrational numbers, classifying them, bringing order to what had seemed chaotic. Eudoxus, who developed the method of exhaustion, an early approach to what would eventually become calculus, finding ways to calculate areas and volumes of curved figures by approximating them with straight-edged shapes whose properties were known. Eudoxus also tackled the problem of proportions, creating a theory that could handle both rational and irrational quantities, bridging the gap that had so troubled the Pythagoreans. His work was rigorous, careful, built on definitions and logical deduction, setting a standard for mathematical precision that would influence all who came after. The Greek mathematical tradition reached a kind of culmination with Euclid, who worked in Alexandria around 300 years before the Common Era, in the great library and museum founded by the Ptolemaic rulers of Egypt, a place where scholars gathered from across the Mediterranean world, where knowledge was collected, preserved, expanded. Euclid's Elements, 13 books covering geometry and number theory, became perhaps the most influential mathematical text ever written, used as a textbook for over 2,000 years, translated into countless languages, studied by generations upon generations of students, not because it contained entirely original discoveries, but because it organized, clarified, and systematized the mathematical knowledge of the Greek world into a coherent logical structure. I imagine Euclid working in the library, surrounded by scrolls, drawing from the work of Thales, Pythagoras, Theaetetus, Eudoxus, and many others whose names are lost, weaving their insights into a unified whole, starting from simple definitions and axioms, building step by logical step, each proposition proved before being used to prove the next, creating a monument of human reasoning. The elements began with definitions. A point is that which has no part. A line is breadthless length, establishing the basic concepts with which geometry would work. Then came the axioms, statements assumed to be self-evidently true, such as the idea that all right angles are equal to one another, or that if a straight line falling on two straight lines makes the interior angles on the same side less than two right angles, the two straight lines, if produced indefinitely, will meet on that side. This last axiom, the fifth postulate, the parallel postulate, would haunt mathematics for centuries. It seemed less self-evident than the others, more complicated, and mathematicians would spend 2,000 years trying to prove it from the other axioms, or to find a simpler formulation. Their failure to do so would eventually lead to one of the most profound revolutions in mathematical thought. But that story belongs to a later chapter of our journey. From Euclid's carefully structured world, mathematics flowed outward like ripples on still water, touching other minds, inspiring new questions, opening territories that had not even been imagined before. Archimedes of Syracuse, born around 287 years before the Common Era, represented a different kind of mathematical genius where Euclid organized and systematized. Archimedes explored and invented, pushing into unknown regions with a combination of geometric intuition and mechanical insight that would not be matched for nearly 2 millennia. I picture him in Syracuse, that Greek city on the coast of Sicily, a place where practical engineering and abstract theory met and mingled, where the defense of the city required inventions, war machines, and clever devices, but where the mind could also soar into pure contemplation, seeking truths that had nothing to do with immediate utility. Archimedes worked on the measurement of curved figures, using the method of exhaustion pioneered by Eudoxus, but taking it further, with greater boldness and creativity, he found the area of a circle, proving that it equals pi times the square of the radius. He calculated the volume of a sphere, showing it to be 2/3 the volume of the cylinder that encloses it, a relationship so beautiful to him that he requested a sphere inscribed in a cylinder be carved on his tomb. His approach involved imagining curves as composed of infinitely many infinitesimally small straight segments, volumes as built up from infinitely many thin slices, ideas that anticipated the integral calculus that would not be fully developed until the 17th century, nearly 2,000 years in his future. But Archimedes also worked with enormous numbers, developing a notation system that could express quantities far beyond the ordinary Greek number system. In his work, The Sand Reckoner, he calculated how many grains of sand would be required to fill the entire universe, not because this had any practical value, but to show that no quantity, however vast, was beyond the reach of mathematical description. I think of him drawing geometric figures in the sand, so absorbed in his contemplations that when Roman soldiers finally breached Syracuse's defenses during the Second Punic War, He supposedly did not even look up. His last words, according to legend, were a plea to the soldier who would kill him. "Do not disturb my circles." The mathematical torch passed from Greek hands gradually as the center of learning shifted from Athens to Alexandria, and as Rome rose to dominate the Mediterranean world. The Romans, for all their engineering prowess, their aqueducts and roads and magnificent buildings, did not contribute significantly to pure mathematics. They were practical people, concerned with what worked rather than why it worked. But in Alexandria, even under Roman rule, the tradition continued. Claudius Ptolemy, working in the 2nd century of the Common Era, created the Almagest, a comprehensive mathematical treatment of astronomy that would dominate Western and Islamic thinking about the cosmos for over 1,000 years. Ptolemy's work required sophisticated mathematics, trigonometry, the geometry of spheres, tables of chords that served the same function as our modern tables of sines and cosines. He created a model of the universe with Earth at the center, using epicycles and deference, circles moving on circles, to explain the observed motions of the planets. It was wrong in its fundamental assumption. The Earth does not sit motionless at the center of creation, but the mathematics was elegant and powerful, capable of making predictions that matched observations with remarkable accuracy. I imagine Ptolemy gazing up at the night sky from Alexandria, watching the planets trace their mysterious paths against the fixed stars, then returning to his scrolls, calculating, adjusting his model, finding the right combinations of circular motions that would reproduce what he observed, mathematics as a tool for making sense of the heavens. The last great mathematician of the ancient world was Diophantus, who worked in Alexandria sometime around the 3rd century. His exact dates lost to the fog of history. He wrote the Arithmetica, a collection of problems focused on finding solutions to equations, particularly solutions in rational numbers. Diophantus worked with what we would now call algebraic equations, though he did not use the symbolic notation that makes modern algebra so powerful. He had symbols for the unknown quantity and for various powers of that unknown, a step toward abstraction, and many of his problems involved finding whole number or rational solutions to polynomial equations, questions that would later be recognized as belonging to number theory, one of the deepest and most beautiful branches of mathematics. His work would lie dormant for centuries, preserved in manuscript form, occasionally copied, but not widely studied, until it was rediscovered during the Renaissance, when it would inspire a new generation of mathematicians to grapple with questions about numbers and equations, questions that are still being explored today. As the Roman Empire fragmented and fell, as libraries burned and the old institutions of learning crumbled in the West, mathematical knowledge might have been lost entirely, but it found refuge in other lands, carried along different routes, preserved in different languages. In India, mathematics had been developing along its own distinctive path, with contributions that would eventually transform the entire discipline. Indian mathematicians worked with numbers in ways that the Greeks had not. They were comfortable with zero as a number in its own right, not merely an absence, but a quantity that could be manipulated, combined with other numbers in calculations. The development of the place value decimal system, where the position of a digit determines its value, and where zero serves as a placeholder, revolutionized calculation. Suddenly, Arithmetic became vastly easier. Multiplication and division that required great skill with the older systems became straightforward procedures that could be taught to children. I picture scholars in cities like Pataliputra and Ujjain working with numbers written on dust boards, developing algorithms for calculation, exploring the properties of numbers. Aryabhata, born in 476 of the Common Era, wrote about mathematics and astronomy, including work on trigonometry and the solution of linear equations. He gave an accurate approximation for pi and understood that the Earth rotates on its axis, an insight that would be forgotten in the West for 1,000 years. Brahmagupta, working in the 7th century, explored what we now call Diophantine equations, after that Alexandrian mathematician who had worked on similar problems centuries earlier. Brahmagupta also worked with negative numbers, understanding them as debts, opposite to positive quantities representing assets. And he gave rules for arithmetic with negative numbers and with zero, rules that we still teach today. These Indian discoveries, the decimal place value system, the concept of zero, the rules for working with negative numbers would travel westward along trade routes carried by merchants and scholars, translated from Sanskrit into other languages, becoming part of a vast exchange of knowledge that flowed across the medieval world. In the Islamic world, from the 8th century onward, a great flowering of learning occurred. Scholars working in Baghdad, Cairo, Cordoba, and other centers collected and translated texts from Greek, Sanskrit, Persian, Chinese, creating libraries that dwarfed anything in Western Europe at that time. Mathematics from different traditions met and merged, creating something new and vital. Muhammad ibn Musa al-Khwarizmi, working in Baghdad in the 9th century at the House of Wisdom, an academy and library established by the Abbasid caliphs, wrote treatises that would shape the future of mathematics. His book on calculation with Hindu numerals helped spread the decimal place value system throughout the Islamic world and eventually into Europe. The word algorithm derives from the Latin version of his name, algorithmi. But al-Khwarizmi's most influential work was his book on algebra, the restoration and balancing, a systematic treatment of solving linear and quadratic equations. The word algebra comes from aljaber, and this book laid the foundations for algebra as a distinct discipline, a way of working with unknown quantities, of manipulating equations to find solutions, of thinking abstractly about numerical relationships. I imagine al-Khwarizmi in the heat of a Baghdad summer, working in the House of Wisdom, surrounded by texts from across the known world, synthesizing Greek geometry with Indian arithmetic, creating methods that were both practically useful for calculating inheritances and dividing estates according to Islamic law, and theoretically interesting, revealing patterns and structures in the world of number. Other Islamic mathematicians extended and deepened this work. Omar Khayyam, known in the West primarily as a poet, author of the Rubaiyat, was also a brilliant mathematician and astronomer. Working in Persia in the 11th century, he developed methods for solving cubic equations using the intersection of conic sections, bringing together algebra and geometry in creative ways. Al-Karaji, working around the year 1000, explored algebra further, working with polynomials, understanding how to manipulate expressions with multiple terms. laying groundwork for later developments. Ibn al-Haytham, known in the West as Al-Hazan, made profound contributions to optics and geometry, exploring the properties of parabolic mirrors, working on problems about the reflection of light. The Islamic mathematicians also preserved and extended Greek geometric traditions. They studied Euclid's Elements intensively, writing commentaries, exploring what could be proved and what required assumption. The parallel postulate particularly fascinated them, and several Islamic mathematicians attempted to prove it from Euclid's other axioms. Their failures, despite great ingenuity and insight, hinted at something profound, that perhaps the parallel postulate was truly independent, that other geometries might be possible, though this radical idea would not be fully developed for centuries. I think of these scholars working in cities that were centers of world civilization at a time when Western Europe was fragmented and poor, its learning confined largely to monasteries. They kept alive not just the mathematical knowledge of the Greeks, but extended it, combined it with insights from India and China, created new methods and new ways of thinking. Mathematics was international, crossing boundaries of language and culture, a shared human endeavor to understand pattern and structure. In China, yet another mathematical tradition had developed independently with its own distinctive character. Chinese mathematicians worked with rod numerals, making calculations on counting boards. They solved systems of linear equations using methods remarkably similar to what we now call Gaussian elimination. They explored magic squares and worked on problems in geometry and number theory. The 9 chapters on the mathematical art, a classic Chinese text whose origins reach back perhaps to the 1st century before the Common Era, though it was compiled and commented upon by later mathematicians, contained problems about agriculture, engineering, taxation, trade, showing mathematics embedded in the practical concerns of civilization, but also revealing sophisticated techniques, methods for finding areas and volumes, for solving equations, for working with fractions and proportions. Liu Hui, working in the 3rd century of the Common Era, wrote a famous commentary on the 9 chapters, providing proofs and explanations. He calculated pi to over 5 decimal places using a polygon of 96 sides, and he understood the method of exhaustion independently of the Greek tradition. Minds across the world, never in contact, reaching similar insights, drawn by the same mathematical truths. All these traditions, Greek, Indian, Islamic, Chinese, represented different approaches to the same underlying reality, different ways of thinking about quantity, shape, pattern, relationship, and slowly, gradually, as trade routes connected distant lands, as travelers carried ideas along with goods, these traditions began to influence one another, to cross-pollinate, creating a richer and more varied mathematical landscape. The Renaissance brought a reawakening to Western Europe as Greek and Islamic texts flooded into Italy through trade with the East and through the fall of Constantinople in 1453. Scholars rediscovered treasures that had been preserved elsewhere while Europe slumbered, and mathematics began to flourish once again in new soil. Leonardo of Pisa, known as Fibonacci, traveled throughout the Mediterranean in the late 12th and early 13th centuries, learning the Hindu-Arabic numeral system. the decimal place value notation that made calculation so much more efficient than Roman numerals. His book Liber Abaci, the Book of Calculation, written in 1202, introduced these numerals to European merchants and scholars, showing their practical advantages for commerce and their theoretical interest for mathematics. I picture Fibonacci watching merchants in North African ports, seeing how quickly they could multiply and divide using these strange new symbols, understanding that this was the future, returning to Pisa to share what he had learned. The book contained many problems, some practical, some recreational, including the famous rabbit problem that would give rise to the sequence bearing his name. 1, 1, 2, 3, 5, 8, 13, each number the sum of the previous two, a pattern that appears mysteriously in nature, in the spirals of shells and the arrangements of leaves. But the true algebraic revolution came in the 16th century, in Renaissance Italy, where mathematics became entangled with pride and competition, public challenges and secret methods. Scipione del Ferro, working in Bologna in the early 1500s, discovered a method for solving certain cubic equations involving the unknown raised to the third power. He kept this method secret, sharing it only with a few students before his death. In that era, mathematical techniques were sometimes guarded like trade secrets, sources of professional advantage. One of Del Ferro's students, Antonio Fior, challenged Niccolò Fontana, known as Tartaglia, the stammerer, due to a speech impediment caused by a childhood injury, to a mathematical duel in 1535. Each would pose problems to the other. The first to solve all the opponent's problems would win. Tartaglia, realizing the challenge would involve cubic equations, worked frantically and discovered the solution method himself, winning the contest decisively. But the story does not end there. Girolamo Cardano, a physician and mathematician of vast ambition and talent, persuaded Tartaglia to share the method, swearing an oath never to reveal it. Cardano then extended the method, solving more general types of cubic equations with the help of his student, Lodovico Ferrari, who also discovered how to solve quartic equations with the unknown raised to the fourth power. I imagine Cardano torn between his oath and his desire for recognition, eventually publishing these methods in his Ars Magna, the Great Art, in 1545, justifying his breach by claiming he had learned that Del Ferro had discovered the method first, making Tartaglia's claim to secrecy invalid. The resulting controversy, bitter accusations, challenges and counter-challenges reveals how intensely personal mathematics could be, how much ego and ambition drove these discoveries alongside pure curiosity. The solution of cubic and quartic equations represented a triumph, but it also revealed something strange and troubling. In the process of solving these equations, mathematicians encountered square roots of negative numbers, quantities that seemed impossible, meaningless, since no number multiplied by itself gives a negative result. Yet if they proceeded with the calculations, treating these impossible numbers as though they made sense, they arrived at correct real number solutions. These imaginary numbers, as they were dismissively called, would haunt mathematics for centuries. Gradually, reluctantly, mathematicians began to accept them, to work with them, to discover that they had profound applications. But that acceptance came slowly, with much resistance and confusion. Meanwhile, in the 17th century, mathematics was being revolutionized in other ways. René Descartes, working in France in the 1630s, brought together algebra and geometry in a powerful synthesis by introducing coordinates, by associating pairs of numbers with points in a plane. He made it possible to represent geometric curves as algebraic equations, and conversely, to visualize algebraic relationships as geometric shapes. I picture Descartes, according to legend, lying in bed watching a fly on the ceiling, realizing that the fly's position could be specified by its distances from two walls, the seat of what would become Cartesian coordinates, analytic geometry, a bridge between two realms of mathematics that had largely developed separately. This same century saw the emergence of calculus, perhaps the single most important development in mathematics since the Greeks. Two men, working independently, arrived at similar insights through different paths. Isaac Newton in England and Gottfried Wilhelm Leibniz in Germany, both grappling with problems of motion and change, of curves and areas, of instantaneous rates and infinite sums. Newton, working largely in isolation during the plague years of 1665 and 1666, when Cambridge University was closed and he retreated to his family home in Woolsthorpe, developed his method of fluxions, a way of calculating instantaneous rates of change, velocities and accelerations, the slopes of curves at specific points. He also developed methods for finding areas under curves, for calculating the distances traveled when velocity varies continuously. Leibniz, approaching similar problems from a more philosophical and formal perspective, developed his own notation, the integral sign, the differential, symbols we still use today. His approach was more systematic, more easily taught and communicated, while Newton's insights were often bound up with physical intuition and geometric thinking. I imagine both men separated by the North Sea and the English Channel, neither knowing the other was working on the same problems, both experiencing those moments of breakthrough when suddenly the fog clears and a new landscape becomes visible, when techniques that had been impossibly difficult become almost routine, when problems that had stymied the greatest minds for centuries yield to new methods. The question of priority, of who discovered calculus first, would lead to a bitter dispute, poisoning relations between English and continental mathematicians for generations. Newton's supporters claimed he had discovered it earlier, even if he published later. Leibniz's supporters argued that independent discovery gave equal credit. The controversy became nationalistic. Ugly, a reminder that even in mathematics, supposedly the most objective of disciplines, human passions and prejudices intrude, but the calculus, regardless of its parentage, transformed mathematics and science. It made possible the precise description of motion and change. It allowed Newton to formulate his laws of motion and universal gravitation, explaining not just falling apples, but the movements of planets. It gave engineers tools to design machines and structures. It opened up entirely new fields of study, differential equations, the calculus of variations, problems that could not even be formulated before. The 18th century saw calculus extended and refined. Leonhard Euler, working in Basel, Berlin, and St. Petersburg, was perhaps the most prolific mathematician who ever lived, writing hundreds of books and papers. making contributions to virtually every area of mathematics known in his time and creating new fields. He worked on number theory, graph theory, topology, mechanics, fluid dynamics, astronomy. Euler introduced much of our modern mathematical notation. The symbol E for the base of natural logarithms, the symbol I for the square root of -1, the function notation f of x. He discovered the beautiful relationship connecting E, I, pi, and the numbers 1 and 0 in a single equation, e to the power of I times pi plus 1 equals 0, a formula that links exponential functions, imaginary numbers, and geometry in a way that still seems almost magical. I picture Euler continuing to work even after going blind in his later years, dictating mathematics to his assistants, calculating in his head, his mental powers so extraordinary that blindness merely changed how he worked. It did not stop him. He saw mathematical relationships with an inner eye that did not depend on physical sight. The Bernoulli family, spanning 3 generations, contributed enormously to mathematics. Jacob and Johann Bernoulli, brothers who were sometimes collaborators, sometimes rivals, worked on calculus and its applications, on problems of curves and surfaces. Johann's son Daniel worked on probability and mathematical physics, hydrodynamics, the study of fluid flow, creating equations that still bear his name. Joseph Louis Lagrange, working in the late 18th century, brought new levels of rigor and generality to calculus and mechanics, seeking to place calculus on a firm algebraic foundation, removing some of the reliance on geometric intuition that had characterized earlier work. He developed the calculus of variations, methods for finding functions that maximize or minimize certain quantities, problems about optimal paths and shapes. What curve will a hanging chain form? What is the shortest path between 2 points on a curved surface? Pierre-Simon Laplace, working through the French Revolution and the Napoleonic era, applied mathematics to celestial mechanics with unprecedented sophistication. His Traité de mécanique céleste, treatise on celestial mechanics, demonstrated that the solar system is stable, that the seemingly irregular motions of the planets would not lead to collisions or ejections, that Newton's laws, combined with the power of calculus, could explain the heavens in exquisite detail. And when Napoleon supposedly asked Laplace where God fit into his system, Laplace is said to have replied, "I have no need of that hypothesis. Mathematics had become powerful enough to describe nature without invoking divine intervention at every step, though whether this represented triumph or loss depended on one's perspective. The 19th century brought revolutions in mathematical thought that would have seemed impossible to earlier generations. Carl Friedrich Gauss, often called the Prince of Mathematicians, made profound contributions to number theory, statistics, astronomy, geodesy, the study of Earth's shape. His Disquisitiones Arithmeticae, published when he was only 24 in 1801, transformed number theory into a systematic discipline, revealing deep patterns in the properties of integers. Gauss also worked on non-Euclidean geometry, exploring what happens if Euclid's parallel postulate is replaced with a different assumption. He discovered that consistent geometries could be built on this alternative foundation, geometries where the angles of a triangle do not sum to 180 degrees, where parallel lines might not exist at all. But he did not publish these findings. perhaps fearing controversy, perhaps not fully grasping their philosophical implications. Others were bolder. Nikolai Lobachevsky in Russia and János Bolyai in Hungary independently developed non-Euclidean geometries, publishing their results in the 1820s and 30s. Initially, their work was ignored or dismissed. The idea that Euclidean geometry might not be the only possible geometry, that mathematical truth might not be absolute and eternal, but dependent on initial assumptions, was too radical for many to accept. But gradually, the mathematical community recognized the validity and importance of these strange new geometries. Bernhard Riemann, in his famous 1854 lecture, generalized the concept further, imagining curved spaces of any dimension, geometries that would later provide the mathematical framework for Einstein's general theory of relativity. Mathematics that seemed purely abstract, disconnected from physical reality, turned out to describe the very structure of space-time itself. I think of how mathematics evolved from practical calculation to abstract theory, from certain knowledge to the recognition that different consistent systems could exist, from a single edifice to a rich landscape of possibilities. The journey had been long, spanning millennia, crossing continents and cultures, and it was far from over, each answer opening new questions, each solution revealing new mysteries to explore. The story of mathematics is not merely a chronicle of discoveries. It is a testament to something fundamental in human nature. This deep hunger to find order, to detect pattern, to understand the hidden structures that govern reality. I think about the continuity, how a Babylonian scribe working 4,000 years ago and a modern mathematician working today are engaged in essentially the same enterprise, asking similar questions, experiencing similar moments of confusion and insight, separated by millennia but connected by the timeless nature of mathematical truth. There is something profoundly democratic about mathematics. A theorem proved in ancient Greece remains true today, accessible to anyone willing to work through the logic, regardless of their station or nationality or era. Mathematical knowledge accumulates, each generation standing on the shoulders of those who came before, adding their own stones to an edifice that grows ever taller and more intricate. The great mathematicians were not superhuman. They struggled, made mistakes, followed dead ends, experienced frustration and self-doubt. What distinguished them was perhaps a certain stubbornness, an unwillingness to accept that something could not be understood, a faith that patient thought could illuminate even the darkest corners of confusion. I picture them in their various settings. Archimedes drawing in the sand, Euler dictating to his assistants, Gauss working in isolation, each absorbed in contemplation, each wrestling with questions that had no obvious answers, no guaranteed solutions, just the possibility, the hope that clarity might emerge from sustained attention. Mathematics reveals itself slowly, reluctantly. A problem that seems impossibly difficult one day becomes almost trivial once the right perspective is found. But finding that perspective might require years, decades, sometimes centuries of collective effort. The history of mathematics is full of problems that resisted solution for generations before finally yielding, and others that remain open still, waiting for the right mind, the right insight. There is beauty in mathematical thought, a kind of austere elegance. When a proof works, when the pieces fit together just so, There is an aesthetic satisfaction comparable to experiencing great art or music. Mathematicians speak of beautiful proofs, elegant solutions, and they mean something real, a quality of inevitability, of rightness that goes beyond mere correctness. The interconnectedness of mathematics astonishes. Discoveries in one area unexpectedly illuminate problems in completely different domains. Number theory connects to geometry, algebra to topology. Abstract structures invented for their own sake turn out to describe physical reality with uncanny precision, as though the universe itself were mathematical at its core, as though beneath the messy complexity of phenomena lay a realm of pure form and relationship. I think about how mathematics changed not just what humans could do, but how they could think. The invention of algebra allowed thoughts that would have been impossible before. The development of calculus opened up entirely new ways of reasoning about change and motion. Each major advance in mathematical notation or technique was simultaneously an expansion of human cognitive capacity, new tools enabling new thoughts. The recognition that different consistent mathematical systems could exist, that Euclidean geometry was not the only possibility, that arithmetic could be done with finite sets of numbers where different rules applied. This pluralism represented a profound philosophical shift. Truth became more subtle, more contextual, dependent on axioms and definitions, yet no less rigorous for that dependence. Mathematics also humbled those who practiced it, revealing the limits of human knowledge. Gödel's incompleteness theorems in the 20th century showed that any sufficiently powerful mathematical system must contain true statements that cannot be proved within that system. There are truths beyond the reach of formal proof, mysteries that resist complete resolution. The dream of reducing all mathematics to a single consistent logical foundation, a dream that animated much 19th and early 20th century work, turned out to be impossible, not because mathematicians were not clever enough, but because of the inherent nature of formal systems themselves. Yet this incompleteness does not diminish mathematics. Perhaps it enriches it, suggesting depths that can never be fully plumbed, ensuring that there will always be new questions to ask, new territories to explore. The journey has no end, only way stations and temporary resting places before the next push forward into the unknown. I imagine the great river of mathematical thought, fed by countless tributaries, contributions from every culture that has contemplated quantity and shape, flowing through the centuries, sometimes moving slowly through periods of consolidation, sometimes rushing forward in rapids of revolutionary insight, carrying all who contributed, from anonymous scribes whose names are lost to celebrated geniuses whose work changed everything, all part of the same current, the same ongoing human conversation with abstract reality. The story winds toward its close now, not because mathematics has ended. It continues, vibrant and alive, new discoveries being made, new connections being forged, but because this particular telling must conclude, must release its hold on these themes and let them settle back into the quiet from which they emerged, I return to that imagined room where this began, the candle burning lower, the shadows deeper now, outside. The night has fully arrived, stars invisible through the window, but present nonetheless, tracing their mathematical paths across the darkness, indifferent to whether anyone watches or calculates their movements. There is comfort in mathematical truth, in knowing that certain relationships hold regardless of circumstance, that 2 plus 2 equals 4, whether anyone believes it or not, whether civilizations rise or fall, whether languages are spoken or forgotten. Some things persist, reliable, unchanging, anchors in a shifting world. The mathematicians themselves have faded into history. Euclid and Archimedes, Al-Khwarizmi and Fibonacci, Newton and Leibniz, Euler and Gauss, their mortal lives long concluded, but their insights remain, transmitted through texts and teachings, living on in every student who works through a proof, every engineer who applies an equation, every scientist who uses mathematical tools to describe nature. I think of mathematics as a kind of collective dream, a shared vision of order and structure built up over thousands of years by countless contributors, each adding their piece, some pieces large and fundamental, others small but necessary, all part of the vast mosaic, the pattern that emerges when human minds turn their attention to the abstract realm of quantity and form. The candle gutters now, the flame dancing one last time before settling into steadiness, a small circle of light in the encompassing darkness. And in this moment, it seems enough to have traced this path, to have followed the thread of mathematical thought through its long and winding journey, from ancient clay tablets to the most abstract modern theories, all part of one continuous story, one ongoing exploration. The room grows quieter, the air still, and the story releases its hold, letting go of names and dates, of theorems and proofs, dissolving back into the peaceful silence from which all stories emerge and to which they return, leaving only the faint echo of wonder, the gentle reminder that beneath the surface of everyday life, patterns wait to be discovered, relationships wait to be understood, and the human mind, curious and persistent, continues to reach toward them, generation after generation, seeking, finding, always seeking further. The light fades, thoughts drift, and in the darkness, numbers dance, silent, eternal, beautiful beyond words. I stand at the edge of a field, and beneath my feet lies something ancient, something alive in ways I have never quite understood until this moment. The soil stretches out before me in every direction, dark and rich and impossibly complex, and I find myself drawn downward in my thoughts, not into the sky or the distant horizon, but into the earth itself, into the quiet world that exists just below the surface of everything I see. The ground here is soft, yielding slightly under my weight, and I notice how the light catches the texture of it, the way each particle seems to hold its own small shadow, its own particular shape. There are colors here I had not expected, not just brown or black, but hints of red, traces of gold, the faintest suggestions of gray and orange where minerals have oxidized over time, where iron has transformed, where clay has settled into its current form after journeys measured not in years but in epochs. I kneel down, and the smell rises to meet me, earthy and profound, a scent that seems to contain multitudes. It is not unpleasant, far from it. There is something almost sweet beneath the mineral tang, something organic and ongoing, the smell of transformation itself, of things becoming other things, of boundaries dissolving between what was once alive and what will live again. When I take a small handful and let it fall slowly through my fingers, I can feel the different textures, Some particles are fine as powder, almost silky, while others are coarser, tiny fragments of rock worn down over time scales I can barely conceive. And there is moisture here too, not wet exactly, but present, as if the soil itself is breathing, drawing water up from below and releasing it in measures so gradual they escape easy observation. I think about what this substance actually is, and the answer unfolds like a story with no clear beginning. This soil was not always here, not in this form. Once, impossibly long ago, there was only rock, bare stone exposed to sun and wind and the patient work of weather, and somehow, through processes both violent and subtle, that rock began to break apart. Frost wedged into cracks and expanded, splitting stone along invisible fault lines. Rain fell and fell again, each drop carrying away the smallest fragments. Wind scoured exposed surfaces, grinding them down grain by grain, particle by particle. But that was only the beginning, because soil is not simply powdered rock. It is something stranger, something that required the arrival of life itself. I imagine the first organisms, microscopic pioneers, bacteria and archaea that found purchase on bare stone, that secreted acids capable of dissolving minerals, that died and left their organic matter as a thin film, a foundation for what would follow. Then lichens, those peculiar partnerships between fungi and algae, spreading across rock faces in patterns like frozen explosions of color. They too contributed, their bodies breaking down stone, their deaths adding layer upon layer of organic material, and then, eventually, plants, first simple ones clinging to whatever soil had accumulated in crevices and depressions, and later, much later, the forests and grasslands that could transform landscapes entirely. Their roots pushed deep, fracturing rock from below. Their leaves fell and decomposed. Their trunks toppled and rotted. Their pollen and seeds and the waste products of their living all mingled with the mineral substrate, creating something entirely new, something that was neither purely mineral nor purely organic, but both, woven together in proportions that varied from place to place, from one handful to the next. I let my eyes trace across the field, and I understand now that every point I see represents a slightly different history. Over there, where the land rises slightly, the soil might be thinner, more recently exposed, while here in this low area, sediment has accumulated over centuries, washed down from higher ground, deposited in layers like the pages of a book written in mud and time. And beneath the surface, right now, invisible to me, but no less real, there is a world of astonishing complexity. A single teaspoon of this soil, just one small measure, might contain more organisms than there are people on Earth. Bacteria numbering in the billions. Fungi sending their thread-like hyphae through the spaces between particles. Nematodes, tiny round worms twisting through films of water. Mites and springtails and creatures without common names, all living their lives in what is to them a vast landscape of caverns and passages and surfaces to traverse. These organisms are not merely present, they are actively creating the soil, transforming it moment by moment. Bacteria decompose organic matter, breaking down complex molecules into simpler forms, releasing nutrients that plants can absorb. Fungi form partnerships with plant roots, extending their reach, trading nutrients for sugars in exchanges so refined they suggest something like negotiation, like cooperation across kingdoms of life. I think about the earthworms I cannot see, but know are here, moving through their tunnels, consuming soil and organic matter, processing it through their bodies, and depositing it transformed. Their castings are richer than the surrounding soil, more fertile. Their tunnels allow air and water to penetrate deeper. Each worm is an engineer, reshaping the underground landscape through the simple fact of its existence, through its hunger and its movement, and its patient tunneling through the dark. And I realize that what I am looking at, what I am touching, is not a static thing, not a stage upon which life performs, but life itself. Soil is alive, not metaphorically, but literally. It breathes in its way, consuming oxygen in the countless metabolisms of its inhabitants. It grows and develops and matures. Young soils are different from old ones, shallow soils from deep. Each has its character, its structure, its particular community of organisms. The light is changing now, growing softer, and the field takes on a different quality. The shadows lengthen, and I can see more clearly the subtle variations in the surface, the places where soil has been disturbed, the paths where nothing grows quite the same. There is history written here in textures and colors, in the distribution of stones, in which plants have chosen to root themselves and which have not. I find myself thinking backward, not in years or decades, but in eons, trying to imagine a time before soil existed at all, when the earth was young and raw, when the surface of the planet bore no resemblance to the quiet field where I now stand. The continents were different then, arranged in configurations that would seem alien, and the atmosphere itself was not the air I breathe now, but something harsher, thinner, incapable of supporting the life that would eventually make soil possible. In those earliest days, perhaps 4.5 billion years ago, the earth was still cooling from its violent formation. Meteors and asteroids struck the surface with devastating regularity. Each impact released energy beyond comprehension, melting rock, vaporizing whatever primitive atmosphere tried to form. The surface was molten in places, a hellscape of lava flows and volcanic eruptions. And there was no soil, no plants, no organic matter of any kind, only sterile rock and ash, and the slow heat of a planet finding its shape. But even then, even in that hostile beginning, the processes that would eventually create soil were starting. The rock cooled and solidified, forming the first solid crust, and immediately the forces of weathering began their patient work. Temperature fluctuations caused expansion and contraction, creating stress within the rock, fracturing it along planes of weakness. Water, when it finally condensed from the cooling atmosphere and fell as rain, found its way into these cracks, and the chemical reactions began. Minerals dissolved, recombined, transformed into new compounds. The first sediments accumulated, washed into low places by the endless rain, settling in layers that would eventually become sedimentary rock themselves. For billions of years, this continued, a world of geology without biology. Rock broke down into smaller and smaller pieces, but it was not yet soil in any meaningful sense. It lacked the essential component, the organic matter that would change everything. The earth was waiting, though of course it did not know it was waiting, for the emergence of life itself. And life came first in the oceans, single-celled organisms so simple they barely qualified as alive by our standards, yet they possessed something miraculous. the ability to reproduce, to metabolize, to change their environment through their existence. For perhaps 3 billion years, these microscopic pioneers remained in the water, evolving slowly, developing new strategies for survival, learning to harness energy from sunlight through the chemistry of photosynthesis, and in doing so, releasing oxygen into the atmosphere, transforming the very air, creating the conditions that would allow more complex life to follow. The land remained barren, sterile expanses of rock, baked by unfiltered sunlight, scoured by wind, carved by water. But the oxygen was accumulating, the atmosphere was changing, and eventually, approximately 450 million years ago, life began its tentative colonization of the terrestrial realm. The first pioneers were likely organisms like cyanobacteria and algae, forming thin films on wet rock surfaces, clinging to existence in the harsh conditions. They were followed by early fungi and simple plant-like organisms, each generation expanding the beachhead, each death contributing organic matter to the mineral substrate. I try to imagine those early landscapes, and they seem impossibly strange. The rocks would have been dark, unsoftened by vegetation, the sky perhaps a different shade of blue. The silence would have been absolute. No birds, no insects, no rustle of wind through grass or leaves, just stone and water and the patient work of organisms too small to see with the naked eye, coating surfaces, dying, accumulating, beginning the transformation from mineral to something more. The first true plants, with vascular systems that could transport water and nutrients, appeared around 400 million years ago. These were simple organisms by modern standards, lacking flowers or seeds, reproducing through spores, but they possessed roots. And those roots changed everything. They pushed into the accumulating sediment, fracturing rock from within, secreting acids that dissolved minerals, extracting nutrients and leaving cavities and passages in their wake. When these plants died, their bodies added substantial organic matter, creating pockets of material that was distinctly different from pure rock, darker, richer, capable of holding more water, more hospitable to the next generation of plants. The pace accelerated. At first, the changes must have been almost imperceptible. A slight darkening of the rock surface, a thin film of organic residue. But as plants diversified and spread, as they grew larger and more complex, the accumulation of soil deepened. By 360 million years ago, there were forests, great stands of primitive trees, ferns and horsetails reaching heights of 30 meters or more. Their roots penetrated deep into the developing soil. Their fallen trunks created massive deposits of organic matter. Their leaves, dropping in seasonal cycles, blanketed the ground, decomposing over months and years, becoming humus, that dark, rich component of soil that holds moisture and nutrients so effectively. And with the plants came the animals, first invertebrates, millipedes, and primitive insects and arachnids, crawling across the forest floor, feeding on the plant matter, on each other, their waste products added to the soil. Their bodies eventually joined it, and they were not passive inhabitants. The millipedes burrowed, mixing organic matter with mineral particles. The insects fed and defecated and died in cycles that processed nutrients through living tissue and returned them transformed. Each organism was part of an increasingly complex system, a web of interactions that created soil, as a byproduct of simply living and dying and consuming and being consumed. Below the surface, invisible but essential, the microbial communities were diversifying. Bacteria specialized in breaking down specific compounds. Fungi developed intricate networks, their hyphae spreading through the soil like neural networks, connecting plants, transferring nutrients and even chemical signals between distant individuals. These fungi could decompose the toughest plant materials, breaking down lignin and cellulose that nothing else could digest, releasing the nutrients locked within, making them available for new growth. The process was self-reinforcing. More plants meant more organic matter, which meant richer soil, which meant more plants could grow and thrive. The soil deepened year by year, century by century. In some places it accumulated to depths of meters, each layer recording the conditions of its formation, the climate, the vegetation, the organisms present at that time. I think about the earthworms, those humble creatures that seem so ordinary, and I learn that they are relative newcomers to the story. The first earthworms appeared perhaps 120 million years ago, long after soil itself had formed, but their impact was profound. An earthworm consumes soil, processes it through its digestive system, and excretes it transformed. A single earthworm might process 10 tons of soil in its lifetime, mixing layers, incorporating organic matter, creating channels that allow air and water to penetrate. In areas where earthworms are abundant, the entire structure of the soil is shaped by their activity, their tunnels and castings creating a texture, an architecture that would not otherwise exist. The continents were still moving, drifting on the plastic mantle beneath, colliding and separating, throwing up mountain ranges and opening ocean basins, and each geological event affected soil formation. Mountains rose, their peaks subject to intense weathering, frost and wind breaking them down. Streams carried the sediment to lowlands, depositing it in fertile floodplains and deltas. Glaciers advanced and retreated, grinding rock to fine powder, leaving behind mineral-rich deposits when they melted. Each climate, each landscape, each combination of parent rock and precipitation and temperature created its own characteristic soil, its own profile of layers and textures and colors. In tropical regions where warmth and moisture combined, decomposition happened rapidly. Organic matter broke down almost as quickly as it fell. The soils became deep, but paradoxically low in nutrients. Everything was cycled so quickly through living organisms that little accumulated. The soils took on reddish hues from oxidized iron. Clays formed and dominated the mineral fraction. In colder regions, decomposition slowed dramatically. Organic matter accumulated in thick layers. The soils were darker, richer in carbon. In wetlands, where water saturation prevented oxygen from reaching the organic matter, decomposition nearly stopped. Peat formed, layers of partially decayed plant material meters thick, recording thousands of years of growth in compressed strata. In grasslands, a different pattern emerged. The grasses sent their roots deep, forming dense mats of living and dead tissue underground. When the roots died, they left channels and added enormous quantities of organic matter. The result was some of the richest soils on Earth, dark and deep and fertile, capable of supporting the immense productivity of prairie ecosystems. I kneel again, running my fingers through the soil, and I understand that what I am touching is the product of all this history. This particular soil formed over thousands of years at minimum, possibly tens of thousands. Each particle arrived through its own journey. Some eroded from distant mountains, carried by wind or water. Some formed in place from the breakdown of bedrock below. The organic matter came from plants that grew here, from the animals that fed on them, from the microorganisms that processed their remains. The profile beneath me, if I could dig down and see it in cross-section, would reveal distinct layers at the surface, the darkest layer, rich in organic matter, where plant roots are most dense, where biological activity is most intense. Below that, a zone where minerals have been altered, where clays have formed, where iron and aluminum compounds have migrated, and deeper still, less altered material, fragments of the parent rock, the source material from which everything above derived. This layering is not arbitrary. It reflects processes. Each horizon tells a story of what happens at that depth, of how water moves, of where roots penetrate, of which organisms can survive. In wetter climates, certain minerals dissolve near the surface and precipitate lower down, creating hard pans and layers of accumulated clay. In drier regions, salts might accumulate, forming white crusts or layers that restrict plant growth. I notice a small depression in the field, and I understand that water collects there, that the soil is different because of it, probably darker, higher in organic matter, perhaps glade, showing the gray colors that develop when soil remains saturated, when oxygen is excluded and iron compounds are chemically reduced. Every variation in the landscape creates a variation in the soil. Every slope and flat, every sunny exposure and shaded hollow develops its own character over time. And through all of this, through hundreds of millions of years of development, soil has been more than just a passive medium. It has shaped the evolution of life itself. Plants adapted to specific soil conditions, developing preferences for certain pH ranges, certain nutrient levels, certain textures. Some plants specialized in nutrient-poor soils, evolving strategies to survive with minimal resources. Others became dependent on rich, deep soils, growing rapidly but unable to tolerate harsh conditions. The distribution of plant species across landscapes is in large part a map of soil variation, each species finding its niche, its preferred substrate, and animals, too, evolved in relationship to soil. Burrowing creatures developed, earthworms and insects, and eventually mammals, using the soil as shelter, as a stable environment protected from temperature extremes and predators. Their evolution in turn shaped the soil, their burrowing and feeding creating new structures, new pathways for water and air, new patterns of nutrient distribution. The field around me grows quieter as the light continues to fade, and I sit here thinking about the immensity of time required to create what I see. The soil beneath me is young in geological terms, perhaps 10,000 years old, formed since the last glaciers retreated from this region. Yet even that span, 100 centuries, is beyond my capacity to truly comprehend. I can recite the number, but I cannot feel its weight, cannot imagine the succession of seasons, the countless cycles of growth and decay, the patient accumulation of organic matter, and the slow transformation of minerals. Yet here it is, real and present, and I find myself wondering about the organisms living within it at this very moment, the invisible multitudes conducting their lives in the darkness below. I think about the bacteria first, because they are the most numerous, the most diverse. A single gram of soil might contain 10,000 different species, each with its own particular role, its own metabolic specialty. Some bacteria are decomposers, breaking down complex organic molecules into simpler forms. They produce enzymes that cleave chemical bonds, that transform proteins into amino acids, carbohydrates into simple sugars. These bacteria are essential. Without them, the nutrients locked in dead tissue would remain unavailable. The cycle would break. The whole system would grind to a halt. Other bacteria are nitrogen fixers, possessing the remarkable ability to take nitrogen gas from the air trapped in soil pores and convert it into ammonia, into forms that plants can absorb and use. This process requires enormous energy, yet these bacteria perform it constantly. Some live freely in the soil, while others form intimate partnerships with plant roots, colonizing special nodules where the plant provides sugars and the bacteria provide nitrogen, a trade that benefits both parties, a cooperation written in chemistry. And there are bacteria that oxidize minerals, that derive energy from transforming iron or sulfur or manganese compounds. They live in realms of pure chemistry, in gradients of oxygen and pH that would be toxic to most life, yet they thrive there, carving out niches in the chemical landscape of the soil. Their metabolisms alter the soil itself, precipitating minerals, creating new compounds, contributing to the weathering that continues even now, even after millions of years. The fungi form their own kingdom of influence. Their hyphae, those thread-like filaments, extend through the soil in networks of astonishing complexity. A single fungal individual might have hyphae stretching for kilometers, woven through a volume of soil, connecting hundreds or thousands of plants. The largest organism on Earth is not a whale or a giant sequoia, but a fungal mycelium in Oregon, covering thousands of acres, all one individual, one genetic entity expressing itself through this vast underground network. These fungi serve many roles. Some are decomposers, particularly skilled at breaking down lignin, that tough polymer that gives wood its structure. They produce enzymes that can cleave its complex bonds, releasing the carbon locked within, making it available for other organisms. When I see a fallen log covered in mushrooms, I am seeing only the fruiting bodies, the reproductive structures. The real organism is inside the wood, digesting it from within, transforming solid timber into soft humus over years or decades. Other fungi form mycorrhizal associations, partnerships with plant roots so ancient and so fundamental that most plants cannot survive without them. The fungal hyphae extend far beyond where roots can reach, exploring tiny pores and crevices, accessing water and nutrients that would otherwise remain beyond the plant's grasp. In return, the plant provides sugars, products of photosynthesis, feeding the fungus that cannot make its own food. The exchange is so finely tuned that the fungus can sense what the plant needs, providing more phosphorus when it is scarce, more nitrogen when that is limiting, adjusting its service to the plant's requirements. And these mycorrhizal networks do something even more remarkable. They connect different plants, even plants of different species. A tree can be linked through fungal hyphae to its neighbors, to seedlings growing in its shade, to plants dozens of meters away. Through these connections, resources can flow. A large tree with deep roots accessing groundwater might share that water through the network with smaller plants suffering from drought. A dying tree might transfer its remaining nutrients to its offspring through fungal intermediaries. The forest is not just a collection of individual trees competing for resources, but a community, interconnected, sharing information and materials through the living internet of fungal mycelia. I imagine this network beneath me right now, invisible filaments crossing and recrossing, forming junctions, creating pathways. It is a landscape at a scale I cannot directly perceive, where distances are measured in micrometers, where a grain of sand is a boulder, where a pore space is a cavern. The organisms at this scale experience the soil as a three-dimensional matrix, a world of surfaces and interfaces and gradients. The nematodes move through this microscopic landscape like serpents, their bodies transparent, elongated. They number in the millions in a square meter of soil, some species feeding on bacteria, engulfing them and digesting them, regulating bacterial populations through predation. Other nematodes feed on fungi, puncturing the hyphae and consuming the contents. Still others are parasites, invading plant roots, or even parasitizing other nematodes. They reproduce rapidly, generations turning over in weeks, their populations fluctuating with the availability of food, with moisture, with temperature. The arthropods are giants by comparison, mites, barely visible to the naked eye, crawl across soil particles like astronauts on an alien world. Some are predators, hunting nematodes and other mites, equipped with specialized mouthparts for grasping and piercing. Others are detritivores, feeding on dead organic matter, shredding leaves and plant fragments into smaller pieces, increasing the surface area available for bacteria and fungi to colonize. Their feeding accelerates decomposition, converts large pieces of litter into fine particulate organic matter that can be more easily processed. Springtails, those peculiar hexapods with their springing appendage, bounce through the leaf litter and upper soil layers. They too are detritivores, but they also graze on fungi, controlling fungal populations, dispersing spores as they move. Their bodies are covered in hydrophobic scales that repel water, allowing them to survive in saturated conditions where other arthropods would drown. In a handful of rich forest soil, there might be hundreds of springtails, representing dozens of species, each with its own feeding preferences, its own tolerance for moisture and temperature. And then there are the larger inhabitants, the ones I might actually see if I dig carefully. Beetle larvae, pale and C-shaped, chewing through organic matter. Their mandibles work constantly, consuming and fragmenting. Their guts contain communities of microorganisms that help them digest, that break down cellulose and lignin. The larvae might spend years underground, growing slowly, accumulating mass, before finally pupating and emerging as adults. Centipedes hunt through the soil, predators equipped with venomous claws, pursuing smaller arthropods. They are fast, agile, sensing vibrations through the soil particles, tracking prey through the labyrinth of pores and channels. Millipedes follow different strategies, moving more slowly, feeding on decaying plant matter, their many legs pushing them through tight spaces, their bodies armored against predators. The earthworms, when present, are ecosystem engineers. Their impact on soil is profound and multifaceted. As they burrow, they consume soil and organic matter, passing it through their digestive system, where it is ground by muscular contractions, mixed with digestive enzymes, inoculated with bacteria from the worm's gut. The castings they deposit are chemically and structurally different from the surrounding soil, higher in nutrients, more stable, better aggregated. A single earthworm might process 40 to 50 times its own body weight in soil each year. Multiply that by the hundreds or thousands of worms in a hectare, and the cumulative effect is staggering. Their burrows create macropores, channels that allow rapid infiltration of water, that permit gas exchange between the atmosphere and deep soil layers. Plant roots follow these burrows, exploiting the paths of least resistance, accessing deeper resources. The burrow walls are lined with mucus and castings, creating surfaces enriched in nutrients, zones of intense microbial activity, hotspots within the soil ecosystem. I think about how these organisms interact, how they form food webs of dizzying complexity. Bacteria consume dead organic matter. Nematodes eat bacteria. Mites eat nematodes. Centipedes eat mites. And when any of these dies, bacteria consume them in turn. The carbon and nutrients cycle through this web, transformed repeatedly, stored temporarily in living tissue, released upon death, reincorporated. The system is dynamic, constantly in flux, populations rising and falling with the seasons, with rainfall, with the availability of fresh organic inputs. And all of this is happening in darkness. The soil organisms live without light, navigating their world through chemical signals, through touch, through vibrations. They sense gradients of oxygen and carbon dioxide. Following these gradients to favorable conditions, they detect the chemical signatures of their food, of their predators, of potential mates. The soil is full of chemical information, pheromones and allochemicals and defensive compounds, a language written in molecules. The structure of the soil itself influences everything. In sandy soils with large particles and large pores, water drains quickly, air penetrates easily, but moisture retention is poor. The organisms here must tolerate fluctuating conditions, periods of plenty alternating with drought. In clay soils with tiny particles packed tightly, water is held more tenaciously, but air exchanges restricted. When saturated, clay soils can become anaerobic, oxygen depleted, favoring different communities of microorganisms, those that can respire using sulfate or nitrate instead of oxygen. The ideal from an agricultural or ecological perspective is a balance, a loam with a mixture of particle sizes, enough large pores for drainage and aeration, enough small pores for water retention, enough clay to hold nutrients, enough organic matter to support biological activity. This structure is not static. It is created and maintained by the organisms living within it. Fungal hyphae bind particles together. Bacterial secretions glue them into aggregates. Roots grow and die, leaving channels. Earthworms mix and churn. The soil is constantly being made and remade by the life it supports. I consider the seasonal rhythms, how the soil changes through the year. In spring, as temperatures rise and moisture from snowmelt saturates the ground, biological activity surges. Microorganisms that were dormant through winter resume their metabolisms. Reproduction accelerates. Plant roots begin their growth, pushing through the soil. secreting compounds that stimulate microbial activity in the rhizosphere, that narrow zone immediately surrounding roots where interactions are most intense. Summer brings warmth, but often brings drought. The surface soil dries. Organisms retreat to deeper layers where moisture persists, or enter dormant states, producing resistant spores or cysts that can survive desiccation. The pace of decomposition slows. Nutrients become less available as microbial activity declines. Plants stress, their roots releasing distress signals that their mycorrhizal partners might respond to, providing more water when possible. Autumn arrives with cooling temperatures and often with rain. A pulse of organic matter falls as leaves drop, as annual plants die back. This fresh input of resources stimulates another surge of activity. Decomposers colonize the new material, fragmenting it, beginning the process of transformation. The soil organisms fatten on this abundance, preparing for winter, storing energy, reproducing one last time before the cold arrives. Winter imposes dormancy on most soil life. Temperatures drop below freezing, at least in the surface layers. Metabolism slows dramatically. Many organisms survive in resistant forms, waiting. Some maintain minimal activity in deeper soil where temperature remains above freezing, where the insulation of snow cover moderates the cold. Ice crystals form in the soil pores, changing the physical structure, sometimes disrupting aggregates, sometimes creating new patterns of cracking and fracturing when freeze-thaw cycles repeat. But even in winter, the soil is not truly dead. Processes continue, just more slowly. Water still moves, albeit sometimes as ice. Chemical reactions still occur, though their rates are reduced. And with the first warmth of spring, everything quickens again. The cycle resumes, endless and renewing. I think about the time scales at which different processes operate. Some bacteria divide every 20 minutes under ideal conditions, their populations doubling and doubling again, reaching enormous numbers in days. Fungi grow more slowly, extending their hyphae millimeters per day, but persisting for years, perhaps decades. Earthworms might live 5 to 10 years, reproducing slowly, investing in long life rather than rapid reproduction. The soil itself changes most slowly of all, accumulating organic matter at rates measured in years per centimeter, developing structure over decades or centuries. Yet within this slow accumulation, within these patient rhythms of growth and decay, something else was beginning, something that would transform the story of soil in ways both profound and troubling. Humans were arriving, and they were noticing the soil, noticing its differences, beginning to understand that their survival depended on it. The first humans were hunters and gatherers, moving across landscapes, following game and seasons. They observed which plants grew where, which soils supported which vegetation. They learned to read the land, to recognize that dark soil in river valleys meant abundant plant growth, that certain soil colors or textures indicated good digging for edible roots, but they did not alter the soil, not intentionally. They were part of the ecosystem, participants in the cycles, but not yet controllers of them. Then, approximately 10,000 years ago, in several different regions of the world, independently, humans began to cultivate plants, to practice agriculture. This changed everything in the Fertile Crescent. In the valleys between the Tigris and Euphrates rivers, people began planting wheat and barley. selecting seeds from the best plants, saving them, sowing them deliberately. They were manipulating the soil now, breaking it with simple tools, removing competing vegetation, concentrating their efforts on small plots where they could tend their crops. The soil responded to this attention. Initially, the yields must have seemed miraculous. The natural fertility accumulated over millennia. The nutrients stored in organic matter and minerals all became available to the crops humans chose to grow. Harvests were abundant. Populations grew. Settlements became permanent. People no longer needed to follow the migrations of animals or the seasonal availability of wild plants. They could stay in one place, building villages, then towns, then cities, all supported by the productivity of cultivated soil. But there was a hidden cost, a consequence that would only become apparent over time. The crops humans planted were mostly annuals, plants that completed their life cycle in a single growing season. Unlike the perennial grasses and deep-rooted plants of natural ecosystems, these crops did not maintain soil structure. Their roots were shallow, offering less organic matter to the soil. And at harvest, the entire plant was removed, taken away to be eaten or stored. The nutrients it contained did not return to the soil. The cycle was broken. Year after year this continued. The soil gave and gave and gave, but received less and less in return. The organic matter content declined. The structure degraded. What had been rich and dark and crumbly became paler, harder, more prone to erosion. Yields began to fall. Sometimes this happened slowly, over generations, so that no single farmer noticed the decline. They only knew that grandfather's stories of abundant harvests seemed exaggerated, impossible. Other times the degradation was catastrophic. In Mesopotamia, the irrigation systems that had seemed so ingenious, that had allowed crops to grow in the desert, began to cause problems. The water they diverted from the rivers carried dissolved salts. When the water evaporated from the fields under the intense sun, the salts remained, accumulating, crystallizing. After centuries of irrigation, some of the most fertile land became too saline to farm. White crusts formed on the surface. Crops withered and died. Civilizations that had thrived for thousands of years found their agricultural base crumbling, their soil, their foundation, turning against them. The Greeks and Romans understood soil fertility to some degree. They practiced crop rotation, alternating wheat with legumes. Though they did not understand the chemistry of nitrogen fixation, they observed that fields planted with beans or lentils seemed refreshed, ready to produce good wheat harvests the following year. They also used manure, recognizing that animal waste improved soil. They wrote treatises on agriculture, on the best practices for maintaining productive land, but they too exhausted soils. The Roman Empire's expansion was partly a quest for new agricultural land, for fresh soils to replace those depleted around the Mediterranean, North Africa. Once the breadbasket of Rome gradually degraded, forests were cleared for timber and farmland, the soil exposed to sun and wind. Without the anchoring roots of trees, without the organic matter from falling leaves, the soil eroded, washed away by winter rains, blown away by summer winds. What had been productive land became progressively more barren. In China, in the river valleys where civilization had flourished for thousands of years, farmers developed sophisticated understandings of soil management. They composted everything, plant waste, animal manure, even human waste, carefully rotted and returned to the fields, they built terraces on hillsides, preventing erosion, conserving both soil and water. They practiced intensive cultivation, supporting large populations on relatively small areas of land, but maintaining fertility through meticulous recycling of nutrients. Yet even there, the pressure of population sometimes overwhelmed sustainable practices. Hillsides were cleared too extensively, soils washed away. Rivers ran thick with sediment during storms, carrying away the topsoil, depositing it in deltas or carrying it out to sea, lost forever to agriculture. The European Middle Ages saw different patterns. After the fall of Rome, populations declined, agricultural pressure on the land decreased, forests regrew, fields were abandoned and returned to nature. The soil had time to recover, to rebuild its organic matter, to restabilize its structure. When agriculture intensified again, the soil had regained much of its fertility, but the knowledge of the Romans had been largely lost. Farmers worked through trial and error, through tradition, through practices passed down without full understanding of why they worked. The introduction of the heavy plow, with its iron blade capable of turning the thick sods of northern Europe, allowed cultivation of previously unworkable lands, but it also exposed soil to erosion, broke up the structure created by perennial grasses. The three-field system, rotating crops and leaving one field fallow each year, helped maintain fertility, gave the soil time to recover between plantings, but yields remained modest by modern standards, and famines were common when weather was unfavorable or when plant diseases struck. Then came a period of global exchange, of colonization and movement of crops and people across continents. European colonizers encountered soils very different from those they knew. In the Americas, in tropical regions, they found soils that seemed poor, thin red clays, low in nutrients, yet these soils supported complex indigenous agriculture. The native peoples had learned to work with what they had, creating raised beds, using biochar, practicing polyculture, growing multiple crops together in patterns that mimicked natural diversity. But the colonizers often ignored these practices. They imposed European methods, clearing forests for single crop plantations. The tropical soils evolved under constant cover of vegetation, degraded rapidly when exposed. The heavy rains leached nutrients, eroded the thin topsoil. Within years, productive land became exhausted. The response was often to clear more forest, to move on to fresh soil, leaving degraded land behind. In North America, European settlers encountered the prairies, grasslands extending beyond the horizon. The soil there was extraordinary, deep and black and rich, accumulated over thousands of years under perennial grasses with their dense root systems. The early farmers broke this prairie with iron plows, turned under the sod, planted wheat and corn. The yields were astounding. The soil seemed inexhaustible, so deep, so fertile. But it was not inexhaustible. The organic matter that had taken millennia to accumulate began to decline. Exposed to air and cultivation, it decomposed rapidly. The soil structure, created by roots and fungi and earthworms, was disrupted with each plowing. The fine particles, no longer bound into stable aggregates, became vulnerable to wind and water. And when drought came in the 1930s, when the rains failed and the winds blew, the soil lifted. Dust storms darkened the sky. topsoil from Kansas and Oklahoma fell as rain in the Atlantic. Farms were buried, abandoned. The Dust Bowl was not just a weather event, it was a soil catastrophe, the consequence of treating soil as an inexhaustible resource rather than a living system requiring care. That crisis prompted changes. Governments promoted soil conservation. Farmers learned to practice contour plowing, to plant windbreaks, to maintain some vegetation cover. The understanding grew that soil was not merely dirt, not just a substrate for holding plants upright, but something complex and precious and vulnerable. Meanwhile, science was beginning to truly understand soil. The microscope revealed the teeming life within. The chemistry of nutrients was unraveled. Nitrogen, phosphorus, potassium, the essential elements, how they moved through ecosystems, how plants acquired them, how they could be depleted, the discovery that nitrogen could be synthesized industrially, converted from atmospheric nitrogen into ammonia through chemistry, seemed to promise freedom from the constraints of natural fertility. Fertilizers could be manufactured, applied to fields. Yields increased dramatically, and they did increase. In the decades after World War II, agricultural productivity soared. The Green Revolution, with its high-yielding crop varieties, its irrigation, its chemical fertilizers and pesticides, allowed population growth unprecedented in human history. Billions of people were fed from land that previously could not have supported them. Famine, while not eliminated, became less common, less catastrophic. But again, there were costs. The heavy use of fertilizers changed soil chemistry. Some nutrients became superabundant while others remained scarce. The balance was disrupted. Soil organisms, adapted to nutrient-poor conditions, to careful recycling, found their environment transformed. Some thrived, others declined. The diversity decreased, and the excess fertilizer, more than plants could absorb, leached away, running into streams and rivers, causing algal blooms. Dead zones in coastal waters where oxygen was depleted. The intensive tillage, the constant disturbance of soil for planting and weed control, continued to degrade structure. Erosion continued, even accelerated in some regions. Measurements showed that soil was being lost faster than it was forming, that the resource was being drawn down, spent. The question arose, how long can this continue? How much soil remains to be lost before agricultural productivity collapses? And there was another realization emerging, that soil is not just important for agriculture, not just a resource for producing food, but plays crucial roles in global systems. Soil stores carbon, enormous amounts of it, more carbon than all the vegetation and the atmosphere combined. As soils degrade, as their organic matter decomposes, that carbon is released, adding to atmospheric carbon dioxide, contributing to climate change, and conversely, healthy soils, well-managed soils with increasing organic matter can sequester carbon, pull it from the atmosphere, store it underground. The way humanity manages soil affects not just food production, but the climate itself, the habitability of the planet. I sit here in this field, touching this soil, and I understand that I am touching history, deep history written in minerals and organic matter, and recent history written in the choices humans have made, in how we have used and sometimes abused this living system. The soil beneath my fingers has fed people, has grown the crops that became bread, that sustained life, generation after generation. And it continues, still living, still functioning, still performing its countless invisible processes, but it is also changed, different from what it would have been without human intervention, perhaps shallower, perhaps less diverse in its microbial communities, perhaps more compacted, more eroded, and yet resilient too, capable of recovery if given the chance, if managed with understanding and care. The light has nearly gone now, and the field around me is settling into quietness, into that particular hush that comes when day releases its hold and something gentler takes over. I remain here, my hands still touching the soil, and I find myself thinking not about what has been, but about what is happening right now, in this moment, beneath the surface, somewhere below me, perhaps only centimeters down. A bacterial cell is dividing, splitting into two identical daughters, each carrying forward the same genetic instructions, the same metabolic pathways. This happens millions of times each second in the soil around me, an explosion of reproduction so vast it defies comprehension. And yet each division is precise, controlled, elegant in its molecular choreography. Nearby, a fungal hypha is extending, pushing forward one microscopic increment at a time, secreting enzymes ahead of itself, dissolving the barriers, absorbing the nutrients released, building new cell wall material and cytoplasm, expanding its reach. In the darkness of the soil, it grows toward gradients, toward food, toward plant roots that might become partners. Its direction is not random but guided, sensing chemical signals, following invisible maps written in concentration gradients. An earthworm contracts its muscles, pushing forward through a channel it has traversed many times before. The soil particles press against its mucus-covered skin. The friction is managed, controlled. The worm pauses, ingests a mouthful of soil and organic matter, grinds it in its muscular gizzard, begins the process of extraction and transformation that will end with castings deposited behind it, richer than what was consumed. A root tip pushes downward, following gravity, following moisture. The cells at the very tip divide rapidly, protected by a root cap that takes the damage of pushing through soil. Behind the tip, cells elongate, the root lengthening, and along its surface, root hairs emerge, delicate extensions that increase surface area 1,000-fold, reaching into the smallest pores, accessing water and dissolved nutrients. Each root hair lives only days, but new ones constantly form, maintaining the interface between plant and soil. I think about the exchanges happening at these root surfaces. Plants release up to 40% of the carbon they fix through photosynthesis into the soil through their roots. It seems wasteful, extravagant, but it is anything but. These exudates, these sugars and organic acids and proteins, feed the rhizosphere community, stimulating the bacteria and fungi that in turn provide services to the plant, breaking down organic matter, releasing nutrients, protecting against pathogens. The plant is farming its own support system, cultivating the microbial community it needs, and the mycorrhizal fungi connected to these roots are at this moment transporting resources. Phosphorus absorbed far from the plant moves through the hyphae molecule by molecule. A gradient is maintained, lower concentration near the root, higher in the soil solution, and the difference drives diffusion, pulls the nutrient toward where it is needed. In return, sugars move from plant to fungus, feeding the network, maintaining the partnership. Water is moving too, always moving, pulled upward by the transpiration of plants, by evaporation from the soil surface, drawn downward by gravity, by the pull of dry soil below. It flows through the largest pores quickly, draining away after rain, and clings in thin films around particles, held by surface tension, by the attraction between water molecules and mineral surfaces. Plants and microorganisms draw on these films, extracting water even from small pores where capillary forces hold it tightly. Gases diffuse through the pore spaces, oxygen from the atmosphere moving inward, consumed by the respiration of roots and soil organisms, carbon dioxide produced by that respiration moving outward. The concentrations in soil air are different from atmospheric air, lower in oxygen, higher in carbon dioxide, reflecting the balance between diffusion and biological activity. When soil becomes waterlogged, when pores fill with water, this gas exchange is blocked, oxygen levels plummet, and the whole community must adapt or perish. I consider the patience required for soil formation, for accumulation. A single centimeter of topsoil might take 500 years to form under natural conditions, perhaps longer, perhaps shorter, depending on climate and parent material and biological activity. But however long it takes, it is slow compared to human lifetimes, slow compared to the processes that can destroy it. A single storm can wash away soil that took centuries to form. A few years of improper cultivation can deplete organic matter that accumulated over millennia. And yet soil is not fragile in the way glass is fragile. It does not shatter irreversibly. It can recover, can rebuild, if, given time and appropriate conditions. Abandoned agricultural land, left alone, begins to revegetate. Grasses colonize first, their roots binding the soil, adding organic matter, then shrubs, then eventually trees. The succession progresses, and with each stage the soil changes, deepens, enriches. Life creates the conditions for more life. The process is self-amplifying, self-organizing, moving toward complexity and stability. There are places where this recovery has been documented. Fields abandoned during the Great Depression, left untouched for decades, have rebuilt soil structure, accumulated organic matter, regained much of what was lost. Not to the original prairie state, perhaps, not in mere decades, but moving in that direction, healing, the knowledge that recovery is possible, that damage is not always permanent, offers something important. Not an excuse for carelessness, but hope that restoration is achievable. I think about the future of soil, about the choices that lie ahead. The human population continues to grow. The demand for food increases. The pressure on agricultural land intensifies. Climate change brings new uncertainties, altered rainfall patterns, more frequent droughts and floods, temperature extremes that stress both crops and soil organisms. The challenges are real and mounting, but there is also growing understanding, new practices emerging, farmers experimenting with no-till agriculture, leaving soil undisturbed, planting directly into residue from previous crops, maintaining structure, preventing erosion, reducing the oxidation of organic matter, cover crops planted between cash crops, keeping living roots in the soil year-round, feeding the soil community, capturing nutrients that might otherwise leach away, adding organic matter when tilled in, composting on a large scale, returning organic waste to agricultural land, closing nutrient loops that have been broken, precision agriculture, using technology to apply fertilizers only where needed in amounts matched to crop requirements, reducing excess, minimizing environmental damage, agroforestry, integrating trees with crops or livestock, creating more complex systems that better mimic natural ecosystems that build soil while producing food. These approaches are not widely adopted yet. They require changes in practice, sometimes changes in equipment or market structures, but they demonstrate that different futures are possible, that agriculture and soil health need not be in opposition, that we can produce food while maintaining or even enhancing the living system that makes production possible. The darkness is nearly complete now. The field has become a study in shadows, shapes barely distinguishable. I can no longer see the soil clearly, but I can feel it, cool against my palms, slightly damp, textured, and I understand that my inability to see it does not mean nothing is happening. The darkness is when much of the soil community is most active, when the heat of day has passed, when moisture persists. The processes continue, indifferent to light or dark, ongoing and essential. I rise slowly, my joints stiff from kneeling, and I stand looking out over the field, thinking about the thin layer of soil covering the planet's surface, thin relative to the Earth's radius, averaging perhaps a meter deep, sometimes less, occasionally more. This thin film is what stands between humanity and starvation, what filters our water, what cycles our nutrients, what stores our carbon. It is easy to overlook, to take for granted, to treat as mere dirt, but it is none of those things. It is alive. It is complex beyond our full understanding, despite centuries of study. It is essential in ways we are still discovering, and it is vulnerable, capable of degradation, of loss, of becoming less than it was. The choices we make, collectively and individually, about how we treat soil will determine not just agricultural productivity, but the functioning of global ecosystems, the stability of the climate, the possibilities available to future generations. The wind moves across the field, carrying scents I cannot quite identify, organic and mineral, present and ancient. I think about all the organisms in the soil beneath me preparing for night, the ones that will become more active and those that will rest, the constant cycling of energy and matter, the exchange between living and non-living, between past and future. And I think about the people who have stood in fields like this throughout history, who noticed the soil, who wondered about it, who learned through trial and error what helped it and what harmed it, who passed that knowledge forward, sometimes successfully, sometimes not, each generation inheriting soil changed by those before, each generation making choices that will affect those after. I am part of that lineage, standing here in this moment, connected backward through time to the first farmers noticing that seeds grew better in certain soils, and forward to people not yet born who will stand in fields and touch soil shaped by what we do now. The responsibility is sobering, but it is also grounding. It places me in a context larger than myself, part of a story still being written. The field is quiet. The soil rests beneath my feet, alive and ancient and ongoing. I can no longer see the individual particles, the subtle variations in color, but I know they are there. I know the processes continue, unseen but real. the bacteria dividing, the fungi growing, the earthworms burrowing, the roots reaching, all of it happening in the darkness, in the silence, patient and persistent, and standing here, feeling the soil beneath me, I understand something fundamental, that I am not separate from this system, not an observer outside looking in. I am made of elements that were once in this soil, that cycled through plants and animals before becoming part of me, and will return to soil when I am gone. The boundary between self and soil is temporary, permeable, illusory in the long view. The last light fades from the western sky. Stars are beginning to appear, distant and cold and beautiful, and beneath them, beneath my feet, the soil continues its quiet work, building and breaking down, cycling and storing, supporting the vast community of life that depends upon it. I take one last handful, let it fall slowly through my fingers, feeling its texture, its slight moisture, its particular character. Then I brush my hands clean, or nearly clean. Some soil remains in the creases of my palms, and I do not mind. I carry it with me, a small connection, a reminder of the living earth beneath all our feet, patient, essential, and worthy of our wonder and our care. I imagine a room lit by candlelight, somewhere in the heart of London, in the year 1700 and something, where the air smells faintly of beeswax and old paper, and outside the window the city settles into its evening rhythm, the clatter of carriages fading, the voices of street vendors growing softer, until there is only the occasional footstep on cobblestone and the whisper of pages turning. There is something about this particular century, this stretch of decades between 1699 and 1800, that feels like the slow unfurling of a new kind of consciousness, as if the English language itself were waking from a long dream, stretching its limbs, finding new shapes and possibilities in the mouths of those who spoke it and the hands of those who wrote it. The books that emerged from this time, they rest now in libraries and private collections, their leather bindings cracked with age, their pages yellowed like autumn leaves. But once they were new, once they were revolutionary, passed from hand to hand in coffee houses where men gathered to argue about philosophy and politics, read aloud in drawing rooms where women debated ideas that the world outside told them were not theirs to consider. I think of a printing press somewhere in a narrow London street, the heavy clunk and rhythm of its operation, the smell of ink, the way each page had to be set by hand, letter by letter, a painstaking process that makes me appreciate every word that survived from that era, every sentence that made it from someone's imagination into permanent form. This was the age when the novel was born, when poetry transformed, when the essay became an art form, when literary criticism emerged as its own discipline, and when the very idea of what literature could be expanded in ways that still shape how we read and write today. But it began quietly, as most revolutions do, with individual voices finding their way onto pages, with readers discovering that books could be something more than religious instruction or classical translation, that they could be mirrors held up to contemporary life, windows into the human heart, maps of the social world, or simply companionship, the 18th century in England. It was a time of paradoxes, of a great wealth and terrible poverty existing side by side, of expanding empire and growing unease about what that expansion meant, of rigid social hierarchies and the first stirrings of the ideas that would eventually challenge them. And all of these tensions and contradictions found their way into the literature. I picture a woman sitting by a window, reading by whatever light she can gather. Perhaps it is morning and the sun slants across her book. Perhaps it is afternoon and she has stolen an hour from her duties. Perhaps it is evening and she reads by candlelight, risking her eyesight for the pleasure of entering another world, of following a story, of encountering ideas that no one speaks aloud in her daily life. Or I imagine a man in a coffee house thick with tobacco smoke, reading a newly published pamphlet or periodical, something printed just days ago, still smelling of ink, containing essays and observations about the city around him, the government, the theater, the scandals and debates of the moment, all of it rendered into prose that is sometimes elegant, sometimes cutting, always engaged with the world as it is, not as classical precedent says it should be. This is the texture of the era, the feeling of it, a world where literature was becoming democratic in new ways, where reading was spreading beyond the university-educated elite, where the middle classes were growing, and with them, a hunger for books that spoke to their experiences, their aspirations, their concerns. The language itself was still settling, still finding its modern form. You can hear it in the prose of the early 1700s, the way it sounds almost but not quite like contemporary English, familiar enough to read without translation, foreign enough to remind you that you are visiting another time, another sensibility, where certain words meant different things, where sentence structures followed different rhythms, where the very act of reading was a different experience than it is now. And yet, despite all these differences, despite the centuries that separate us from those readers and writers, something essential connects us, the human need to tell stories, to make sense of experience through language, to create beauty out of words, to argue and persuade, to entertain and move, to leave some trace of consciousness behind. I think of all the voices that spoke through 18th century English literature, the famous ones whose names we still know, and the forgotten ones, the authors of single novels that disappeared, the poets whose work was published once and never again, the essayists and journalists whose words filled the periodicals of their day and then vanished. All of them part of this vast conversation, this ongoing exploration of what writing could do, what it could be. And so we begin here in this moment of transition, when the old forms were not yet gone, but the new ones were emerging, when literature was becoming something recognizably modern, even as it remained rooted in classical tradition, when the book trade was expanding, when literacy was spreading, when the very idea of the author as we understand it today was taking shape. The candle burns lower, the light grows softer, and we prepare to explore this landscape together, to walk through the decades, to meet the writers and their works, to understand the world that shaped them and that they in turn helped to shape. The story truly begins in the final years of the 17th century, when England was emerging from decades of political turmoil, the Civil War and the Restoration still within living memory, and the glorious revolution of 1688 had just reshaped the monarchy, creating a new settlement between crown and parliament, a new sense of what English society might become. In 1688, the same year that William and Mary took the throne, John Locke published his essay concerning human understanding, a work of philosophy that would ripple through the literature of the coming century, with its insistence that the mind begins as a blank slate, that knowledge comes from experience, that human beings are shaped by their environments and educations. These ideas would influence novelists and poets for generations, giving them permission to explore how characters develop, how circumstances form personality, how the individual consciousness works. But it was in 1690, just as the new decade began, that something else happened. Something that might seem small but was actually seismic in its implications. The Licensing Act lapsed, and for the first time in over half a century, English printing was freed from government pre-censorship, the floodgates opened, and suddenly anyone with access to a printing press could publish almost anything. Pamphlets and periodicals multiplied, political satire flourished, and the public sphere, as we understand it, began to take shape. The coffee houses of London became sites of literary exchange, gathering places where men from different classes and professions could meet, argue, share news and ideas. By 1700, there were perhaps 500 coffee houses in London alone, each one developing its own character, its own regular clientele. Some catered to merchants, others to lawyers or doctors, still others to writers and artists. And in these spaces, literature was discussed, debated, created. I imagine walking into one of these establishments, pushing open a heavy door, stepping into a fog of tobacco smoke and the rich, dark smell of coffee, a luxury imported from distant lands, finding a seat at a long table beside strangers who might become collaborators or rivals, listening to someone read aloud from a new publication, hearing the laughter or outrage that greets a particularly sharp piece of satire. It was in this world, this London of coffee houses and expanding print culture, that the periodical essay was born in 1709. A writer named Richard Steele, a man with a gift for observation and a talent for debt, began publishing a small paper called The Tatler. It appeared 3 times a week, and it did something new. It blended news with entertainment, reporting with reflection, creating a voice that was urbane, witty, and accessible. Steele wrote under the pseudonym Isaac Bickerstaff, a fictional character with opinions about everything from fashion to philosophy, and readers loved it. They felt as if they were being admitted into a conversation, as if this genial narrator were speaking directly to them, sharing his thoughts about the passing scene, the absurdities of social life, the small dramas of London streets and drawing rooms. Within a year, Steele had been joined by his friend Joseph Addison, a more polished writer, more classically educated. Together they created something that had never quite existed before, a form of essay that was learned but not pedantic, moral but not preachy, entertaining but not frivolous. They were teaching their readers how to think, how to observe, how to live as refined and rational beings, and they were doing it 3 times a week in affordable installments. When the Tatler ended in 1711, Addison and Steele immediately launched something even more ambitious. The Spectator, which appeared 6 days a week, and introduced another fictional narrator, Mr. Spectator, a man who claimed to observe everything and say nothing in company, saving all his eloquence for the page. The reach of The Spectator was extraordinary. Each issue might be read by dozens of people, passed from hand to hand in coffee houses, read aloud in homes, discussed and debated. Addison and Steele were shaping taste, influencing opinion, creating a sense of what it meant to be civilized, to be modern, to be English in this new century. They wrote about literature and theater, about the follies of fashion and the importance of moral virtue, about the need for religious tolerance and the dangers of political extremism. They created recurring characters. Sir Roger de Coverley, the kindly country gentleman, Sir Andrew Freeport, the merchant, Captain Sentry, the soldier, each representing a different strand of English society, and through their gentle interactions, readers learned to see their world with new eyes. But while the periodical essayists were teaching readers how to think and observe, another revolution was quietly beginning in the realm of prose fiction for centuries. Narrative prose in English had mostly taken the form of romance, tales of knights and ladies, improbable adventures, allegorical journeys, stories set in distant times and places, offering escape but not reflection on contemporary life. What if prose fiction could do something different? What if it could represent the world as it actually was, the lives people actually lived? What if it could explore the inner workings of consciousness, the moral choices ordinary people faced, the social pressures that shaped behavior and destiny? In 1719, a man named Daniel Defoe, already in his late 50s, already the author of hundreds of political pamphlets and works of journalism, published a book called Robinson Crusoe. It purported to be the true account of a sailor shipwrecked on an island, alone for decades, surviving through ingenuity and faith, and readers devoured it, not as fantasy, but as something that felt real, convincing, immediate. Defoe had stumbled onto something, or perhaps he had deliberately crafted it, a prose style that mimicked reality, that accumulated detail upon detail, that followed the rhythms of actual experience rather than the conventions of romance. His Crusoe kept accounts, inventoried his possessions, described the practical steps of building shelter and finding food, and in all this mundane specificity, readers found something transfixing. The book became a sensation, and Defoe, sensing opportunity, quickly produced more in 1720. Memoirs of a Cavalier and Captain Singleton in 1722, his masterpiece, Moll Flanders, the supposed autobiography of a woman born in Newgate Prison who becomes a thief, a seductress, a transported convict, and finally a penitent, all narrated in her own voice, direct, unadorned, morally complex. Moll Flanders was not a heroine in any conventional sense. She was calculating, often amoral, driven by the need to survive in a world that offered women few respectable options, and yet, in Defoe's hands, her story became compelling, even sympathetic, because it felt true to the realities of life, especially for those without wealth or status or family protection. What Defoe had created, though he might not have called it this, was something approaching the novel as we understand it, prose fiction that took ordinary life as its subject, that developed character through accumulated detail and choice, that explored the relationship between individual and society, that made readers care about people who resembled themselves more than they resembled heroes of romance. And he was not alone. In 1726, a clergyman and satirist named Jonathan Swift published Gulliver's Travels, ostensibly another travel narrative, another tale of adventure in distant lands, but actually a savage satire of human nature, of politics, of the pretensions of science and learning, of empire and war. Swift's genius was to use the form of the travel narrative, already popular, and twist it into something strange and disturbing. Gulliver visits lands of tiny people and giants, of rational horses and bestial humans, and with each voyage, Swift's vision of humanity grows darker, more pessimistic, until by the final book, Gulliver returns home unable to bear the sight or smell of his own family, preferring the company of horses. It was published anonymously, but everyone knew who had written it, and it became an immediate bestseller, read by everyone from children who enjoyed the adventure to politicians who recognized themselves in Swift's portraits of corruption and folly. It showed that prose fiction could be a vehicle for serious ideas, for philosophical inquiry, for social criticism of the sharpest kind. These early decades of the 18th century, this period from roughly 1700 to 1730, were years of experimentation and discovery. Writers were learning what prose could do, how it could capture experience, represent consciousness, satirize society, entertain and instruct simultaneously. The language they used was still forming, still finding its rhythms. You can hear in Defoe's sentences the influence of journalism, of the plain style that valued clarity over ornament. In Swift you hear something more elaborate, more controlled, the prose of a classicist who had read his Latin authors and learned from them the arts of irony and structure. And beneath all of it, beneath the coffee houses and the periodicals, the emerging novels and the satirical fictions, was the expansion of the reading public. More people were learning to read. The middle classes were growing, and they wanted books. They wanted stories. They wanted to see their world reflected, examined, transfigured through language. The book trade responded. Publishers proliferated. Circulating libraries began to appear, where readers could borrow books for a small fee rather than purchasing them outright, making literature accessible to those who could not afford to buy. Serialization became common, long works appearing in installments, creating suspense and anticipation, building audiences. Women were reading, and increasingly women were writing, though often anonymously or under male pseudonyms. Eliza Haywood published numerous works of fiction in the 1720s and 30s, passionate, scandalous stories of love and betrayal that sold enormously well, even as critics dismissed them as frivolous, as corrupting to morals, as beneath serious literary consideration. But they were read widely, hungrily, and they met needs that the more respectable literature did not, needs for emotional intensity, for exploration of desire, for stories centered on women's experiences, on the limited choices available to them, on the marriages that determined their fates, the tension between respectability and popularity, between moral instruction and entertainment, between classical learning and contemporary relevance. These tensions ran through all of 18th century literature, and they were already visible in these early decades in the debates about what literature should be, what it should do, who should write it, Who should read it? By 1730, the landscape was set. The periodical essay had established itself. Prose fiction had emerged as a legitimate, even important form. Satire flourished, and poetry, though we have not yet spoken of it, continued in both its classical modes and in new experimental directions. The stage was prepared for what would come next, for the full flowering of the novel, for the great works of mid-century, for the voices that would define the age. But already, in these first 30 years, something fundamental had shifted. Literature in English had become modern, recognizably so, and there was no going back. The 1730s arrived, and with them came a shift in the literary atmosphere. Something was gathering, a sense that prose fiction could be more than satire or adventure, that it could explore the human heart with the depth and seriousness that had previously belonged to poetry and drama alone. In 1740, a printer named Samuel Richardson, a man of modest origins who had built a successful business, who had never attended university, who lived a quiet life in the suburbs of London, published a novel that would change everything. He called it Pamela, or Virtue Rewarded, and it told the story of a young servant girl who resists the sexual advances of her master, maintaining her virtue through hundreds of pages of attempted seduction, until finally he offers her marriage, elevating her to his own rank. Richardson had written the book almost by accident. He had been compiling a volume of model letters for those unaccustomed to writing, and the letters began to form a narrative, a story told entirely through correspondence, giving readers direct access to Pamela's thoughts and feelings, her fears and hopes, moment by moment, day by day. The effect was unlike anything readers had experienced before. They felt as if they were reading actual letters, as if Pamela were a real person, as if her struggles and triumphs were happening now, in real time. The epistolary form created an intimacy, an immediacy that third-person narration could not match, and the public response was extraordinary. Sermons were preached about Pamela's virtue. Editions sold out. Translations appeared across Europe. Fan letters poured in, though there was also fierce criticism. Some readers found Pamela calculating rather than virtuous. Others objected to the implication that a servant could marry her master, that class boundaries could be crossed, that social hierarchy was not divinely ordained and immutable. Richardson had touched something raw, something essential about his society and its anxieties, about class and gender, about virtue and reward, about whether moral worth could outweigh social station, and he had done it through the novel, through prose fiction, demonstrating that this form could engage with the deepest questions of how to live, how to be good, how to navigate a world of power and desire. He followed Pamela with an even more ambitious work. Clarissa, published in 1748, a massive novel, over 1 million words, told through letters exchanged among multiple correspondents the story of a young woman of good family, trapped between her parents' demand that she marry a wealthy man she despises and the seductive promises of a charming rake named Lovelace. Clarissa tries to escape, and in doing so falls into Lovelace's power. He kidnaps her, imprisons her in a brothel, and finally, when all his attempts at seduction fail, he drugs and rapes her. And from this violation there is no recovery. Clarissa wastes away, maintaining her moral purity even as her body fails, and dies, a martyr to virtue in a world that cannot protect innocence. It is a dark book, a tragic book. Readers wept over it, begged Richardson to let Clarissa live, to marry Lovelace, to find happiness. But Richardson refused. He understood that the power of his novel lay precisely in its refusal of easy comfort, in its insistence that virtue did not always triumph, that good people suffered, that the world was not just, and that this injustice demanded recognition, demanded grief, demanded change. The novels took hours to read, days, weeks. Readers immersed themselves in the minutiae of feeling, the subtle shifts of emotion, the moral deliberations, the letters that captured every nuance of consciousness. Richardson had created a new kind of realism, not Defoe's realism of external detail and circumstance, but a realism of interiority, of the inner life rendered with unprecedented fullness and precision. But not everyone admired Richardson's approach in 1749. A novelist and playwright named Henry Fielding published Tom Jones, a vast comic novel that seemed designed as a deliberate alternative to Richardson's intense psychological focus, where Richardson was earnest and sentimental. Fielding was ironic and worldly, where Richardson trapped readers in the consciousness of his heroines. Fielding adopted the stance of an omniscient narrator, commenting, joking, guiding readers through the story with a knowing wink. Tom Jones is a foundling, a young man of unknown parentage raised by a kind country squire, good-hearted but impulsive, generous but reckless. The novel follows his journey from the countryside to London and back again, through a series of adventures and misadventures, love affairs and fights, deceptions and revelations, all narrated with wit and energy and a deep sense of human comedy. Fielding believed that the novel should represent life in all its variety, its mixture of high and low, serious and comic, virtue and vice. He filled his pages with characters from every level of society, servants and aristocrats, clergymen and soldiers, innkeepers and landladies, prostitutes and ladies of quality, all rendered with sympathy and humor, all revealing the contradictions and complexities of human nature. His narrative voice was revolutionary. He addressed the reader directly, paused to offer essays on criticism and morality, compared himself to a landlord serving up a feast, with each book of the novel a different course. He made the act of narration itself visible, playful, part of the pleasure of reading, where Richardson wanted readers to forget they were reading fiction. Fielding constantly reminded them and invited them to enjoy the artifice, the craft, the storytelling, between Richardson and Fielding, between sentiment and satire, between psychological depth and social breadth. The English novel found its range, discovered what it could do, and readers discovered what they wanted. Some preferred Richardson's tears, others Fielding's laughter. Most probably read both, enjoying the contrast, the different pleasures each offered. The 1740s and 50s were the novel's coming of age, but poetry had not stood still. Alexander Pope, who had dominated the early part of the century with his brilliant satirical verse, had died in 1744, leaving behind works like The Rape of the Lock, a mock epic about a stolen lock of hair that became a meditation on vanity and social pretension, and the Dunciad, a savage attack on all he saw as dull and mediocre in contemporary writing. Pope had perfected the heroic couplet, pairs of rhyming lines in iambic pentameter, making them vehicles for wit and argument, for elegant turns of phrase that lodged in memory. His poetry was urbane, classical, controlled, every word carefully chosen, every line polished until it gleamed. But even before Pope's death, other voices were emerging. Edward Young published Night Thoughts beginning in 1742, a long meditation on death and immortality, written in blank verse rather than couplets, more emotionally expressive, more willing to embrace darkness and melancholy. It signaled a shift, a movement toward what would later be called sensibility, an aesthetic that valued feeling over wit, sublimity over polish, the natural over the artificial. Thomas Gray's elegy, written in a country churchyard, published in 1751, became immediately famous. It was everything Pope's poetry was not, meditative rather than satirical, melancholic rather than witty, set not in London's drawing rooms, but in a rural graveyard at twilight, among the graves of the forgotten poor. The poem mourned not just individual deaths, but lost potential, all the Miltons who died mute and inglorious, all the talent wasted by poverty and obscurity. Readers loved it, memorized it, quoted it. It spoke to something in the culture, a growing sense that feeling, that sensitivity to suffering, that recognition of common humanity, mattered more than classical learning or social rank. The poem was elegiac, not just for the dead, but for an older literary culture giving way to something new. The 1750s brought other developments. Samuel Johnson, a towering figure of learning and moral authority, published his Dictionary of the English Language in 1755. A massive work of scholarship that took him 9 years to complete. It was the first comprehensive dictionary of English, defining over 40,000 words, illustrating their usage with quotations from literature, standardizing spelling and meaning, giving the language a stability it had previously lacked. Johnson was also a brilliant essayist. His periodical The Rambler, published twice weekly from 1750 to 1752, continued the tradition of Addison and Steele, but with a more serious, more philosophical bent. Johnson wrote about morality and human nature, about the disappointments of ambition, the consolations of learning, the importance of facing reality without illusion. His prose was dense, Latinate, challenging, but also powerful, capable of a great beauty and insight. And he wrote a novel, Rasselas, published in 1759, supposedly to pay for his mother's funeral. It told the story of an Abyssinian prince who escapes his comfortable prison in the Happy Valley to search the world for the secret of happiness, only to discover that no condition of life, no choice of profession or marriage or philosophy, guarantees contentment, that human existence is fundamentally difficult, and that wisdom lies in accepting this truth without despair. It was a dark conclusion, but Johnson meant it as a kind of comfort. If happiness is impossible to secure, then its absence is not failure, is not your fault. The book counseled lowered expectations, steady virtue, and the pleasures of friendship and intellectual engagement. It was philosophy disguised as Oriental tale, and it sold widely, meeting readers in their own disappointments, their own discoveries that life did not match their hopes. The 1760s brought new voices still. Lawrence Sterne published the first volumes of Tristram Shandy in 1759 and continued the work through the next decade, creating something utterly unlike any novel before it, a supposed autobiography that constantly digressed, that played with typography and page layout, that included blank pages and marbled pages, that stopped to address the reader, to argue with critics, to pursue tangents that went nowhere. Sterne was fascinated by consciousness itself, by how the mind works, how memory and association lead thoughts in unexpected directions, how time feels different from how it measures. Tristram tries to tell the story of his life but cannot get past his own birth because every detail requires explanation. Every explanation opens new avenues, and before long the narrative has wandered far from its ostensible subject into meditations on noses and names, on warfare and hobby horses, on 1,000 topics both profound and absurd. Some readers were delighted, others baffled. Critics often condemned it as formless, as self-indulgent, as a violation of every rule of good writing, but it was enormously popular, and it showed that the novel was not settling into fixed conventions, that it remained a space for experiment, for play, for testing the boundaries of what prose narrative could be. The same decade saw the publication of The Castle of Otranto in 1764 by Horace Walpole, a short novel that invented the Gothic, setting its story in a medieval Italian castle, filling it with prophecies and ghosts, with threatened maidens and tyrannical lords, with secret passages and mysterious manuscripts. It was deliberately archaic, turning away from contemporary realism toward romance and terror, toward the irrational and supernatural. Walpole published it anonymously at first, claiming it was a translation of an old Italian manuscript, and when it succeeded, he revealed himself as author and he defended his choice, arguing that imagination needed room to roam, that the marvelous had its place in literature, that the novel need not always represent ordinary life. It could create its own worlds, its own laws, and in doing so, explore fears and desires that realism could not touch. The Gothic would become enormously influential, spawning countless imitators, evolving into different forms. But even in this first iteration, it showed the novel's capacity to reinvent itself, to move between modes, to be realistic or fantastic, comic or tragic, experimental or conventional. The form was proving capacious enough to contain multitudes. By the 1770s, English literature had grown rich and various, but it was also beginning to turn inward, to become more concerned with individual feeling, with the cultivation of sensibility, with the capacity to feel deeply, to sympathize, to be moved by beauty and suffering alike. The cult of sensibility, as it came to be known, valued emotional responsiveness as a moral quality. Those who could weep at a tale of distress, who trembled at injustice, who felt the sublime in nature, were considered morally superior to those who remained unmoved. Literature became a vehicle for testing and displaying this sensitivity. Novels featured scenes designed to provoke tears. Poetry dwelt on loss and melancholy, and readers measured their own worth by the intensity of their responses. Henry Mackenzie's The Man of Feeling, published in 1771, became the emblematic novel of this movement. Its protagonist, Harley, wanders through a series of encounters with suffering, weeping at every turn, helping where he can, unable to protect himself from the cruelty and calculation of the world. The novel is episodic, fragmented, supposedly reconstructed from torn manuscript pages, and it celebrates Harley's sensitivity even as it shows how ill-suited he is to survive in a harsh society. Readers wept over it, carried it with them, marked the passages that moved them most. The book became a kind of permission, a validation of feelings that the dominant culture often demanded be suppressed or controlled, especially in men for whom displays of emotion were suspect. Harley proved that a man could be both good and emotionally vulnerable, that tears were not weakness, but evidence of a refined soul. But sensibility had its critics. Some saw it as self-indulgent, as valuing feeling over action, as a kind of moral theater where one performed sensitivity without actually helping those in need. And in the hands of less skilled writers, novels of sensibility could become formulaic, mechanical in their production of predictable emotional effects. Tears shed according to schedule, virtue rewarded with implausible regularity. The novel was maturing, becoming self-aware, capable of examining its own conventions and assumptions, and nowhere was this more evident than in the work of Frances Burney, who published Evelina in 1778, when she was just 26 years old, and did so anonymously, unsure whether a woman's novel would be taken seriously. Evelina told the story of a young woman entering London society, navigating its complexities, its dangers, its absurdities. The novel was epistolary in Richardson's tradition, but lighter, more comic, more socially observant. Burney had a gift for dialogue, for capturing the rhythms of speech, the ways different classes and characters revealed themselves through language, and she used this gift to create a vivid portrait of contemporary social life, with all its pretensions and hypocrisies. The novel was a sensation. Everyone read it, tried to guess the author. When Burney's identity became known, she found herself celebrated. Dr. Johnson himself praised her work. She had proven that women could write novels that were both popular and critically respected, that dealt seriously with women's limited options, their vulnerability in a society that gave them little power, while also being entertaining, witty, pleasurable to read. Burney would write more novels, but none quite captured the freshness of Evelina, that sense of a new voice, a new perspective, entering literature and claiming space within it. She paved the way for the women novelists who would dominate the next century, showing that domestic life, courtship and marriage, the social education of young women, could be the stuff of serious art. The 1780s saw the continuation of these trends, but also the first stirrings of something else, a new interest in the poor, the rural, the traditional ways of life that industrialization and enclosure were destroying. Oliver Goldsmith's The Deserted Village, published in 1770, had already mourned the depopulation of the countryside, the loss of agricultural communities to commercial farming, and now other poets took up similar themes. George Crabbe, a clergyman who knew rural poverty firsthand, published The Village in 1783. It was a deliberate response to the pastoral tradition, to poems that idealize country life as peaceful and innocent. Crabbe showed the reality, the backbreaking labor, the hunger, the diseases, the harsh treatment by landlords, the miserable old age awaiting those who had worked the land all their lives. His poetry was unflinching, almost documentary in its detail, refusing to prettify or romanticize. And yet, even as Crabbe insisted on harsh realities, Others were beginning to find in nature and rural life a different kind of value, not pastoral innocence, but something wilder, more sublime, more spiritually significant. William Cowper's The Task, published in 1785, was a long discursive poem that moved between descriptions of nature, meditations on religion, and commentary on contemporary society. It was personal, conversational, finding in the landscape around his rural home a source of solace and meaning. Cowper suffered from severe depression, from religious despair, and his poetry became a way of holding these terrors at bay, of finding reasons to continue. The natural world offered him comfort that human society could not, and his readers responded to this, to the sense of a genuine voice, a real person struggling with darkness and finding glimpses of light, of grace in ordinary things, a winter walk, a greenhouse, the sounds of wind and rain. The 1780s also brought political upheaval that would reshape literature. The American Revolution had already demonstrated that colonial peoples could throw off imperial rule, could create new forms of government. And in 1789, the French Revolution began with its promise of liberty, equality, fraternity, its challenge to hereditary privilege, its assertion of universal human rights. English writers and intellectuals watched with a mixture of hope and fear. Some, like William Godwin, who published Political Justice in 1793, saw the revolution as the dawn of a new age, the triumph of reason over superstition, of merit over inherited rank, of human potential over the dead weight of tradition. Godwin argued for anarchism, for the gradual elimination of government itself as reason spread and people learned to live together without coercion. Others, witnessing the terror, the mass executions, the descent into violence and authoritarianism, recoiled. Edmund Burke's Reflections on the Revolution in France, published in 1790, became the founding text of modern conservatism, arguing that society was an organic growth, a partnership between the living, the dead, and those yet to be born, and that radical attempts to remake it according to abstract principles would end in disaster. As indeed they seemed to be doing, the debate between Burke and his radical critics, including Mary Wollstonecraft and Thomas Paine, played out in pamphlets and treatises, in poetry and novels. Literature became explicitly political, taking sides, arguing for competing visions of the good society, and this politicization would mark the 1790s profoundly. Mary Wollstonecraft, best known now for A Vindication of the Rights of Woman, published in 1792, also wrote novels, including Maria, or The Wrongs of Woman, left unfinished at her death in 1797. These works combine political argument with emotional intensity, showing how women's oppression was not just abstract injustice, but lived reality. Marriages that were legal prostitution, property laws that left women destitute, educational systems that deliberately kept them ignorant. Her contemporary, Anne Radcliffe, was creating a different kind of novel. Gothic romances like The Mysteries of Udolpho, published in 1794, that took readers to remote castles in the Pyrenees, through dark corridors and secret chambers, where heroines confronted apparent supernatural horrors that turned out in Radcliffe's hands to have rational explanations. Her novels were enormously popular, and they showed that Gothic fiction could be respectable, could appeal to educated readers, could combine thrills with moral seriousness. The 1790s also saw the emergence of the Romantic poets, though they would not reach their full flowering until the next century. William Blake had been publishing and illustrating his visionary poetry since the 1780s, creating works like Songs of Innocence and Experience that saw the world split between opposing states, childhood and adulthood, joy and suffering, freedom and oppression. Blake worked outside the literary mainstream, engraving his own books by hand, selling few copies, but creating a body of work that was utterly original, mystical and political at once, crying out against the dark satanic mills of industrialization, the mind-forged manacles of conventional thinking. William Wordsworth and Samuel Taylor Coleridge met in 1795 and began the collaboration that would produce Lyrical Ballads in 1798, a collection of poems that would retrospectively be seen as marking the beginning of English Romanticism, though at the time it appeared anonymously, modestly, with little fanfare. The preface Wordsworth wrote for the 1800 edition laid out a new poetics. Poetry should use the language really spoken by people, not artificial poetic diction. It should take as in its subjects incidents and situations from common life, and it should be informed by imagination, by feeling, by the poet's emotional response to experience. These ideas were not entirely new, but Wordsworth articulated them with clarity and force, creating a manifesto, a call to transform poetry, to make it more democratic, more authentic, more alive. The 18th century was ending, and with it, a certain kind of literary culture, the dominance of the couplet in poetry, of rational satire, of the periodical essay as arbiter of taste. The novel had established itself, proven its worth, demonstrated its range. Poetry was turning toward nature and the imagination, toward childhood and memory, toward revolution and vision. But the century's literature remained, its books still read, still influential, still shaping how writers and readers understood what literature could be. The novels of Richardson and Fielding, the essays of Addison and Johnson, the satires of Pope and Swift, the Gothic inventions of Walpole and Radcliffe, the sensibility of Sterne and Mackenzie, all of it now part of a tradition, a heritage, a conversation that continued across generations. The literature of the 18th century had been many things, comic and tragic, realistic and fantastic, conservative and radical, polished and experimental. It had explored human nature in all its variety, had held a mirror to society and found it wanting, had created new forms and perfected old ones, had made space for voices previously excluded, had argued about everything from politics to aesthetics to the nature of virtue itself. And in doing all this, it had made literature central to English culture in new ways. Reading had become not just a pastime for the educated few, but a practice that shaped consciousness, formed opinion, created communities of readers who saw themselves as part of a public, citizens of a republic of letters, where ideas could be debated, where stories could offer both escape and understanding, where language itself was recognized as power, as art, as one of the supreme human achievements. The books remain, sitting on shelves in libraries and private collections, their pages turned by countless hands over the centuries, each reader bringing their own life to the encounter, finding their own meanings, their own connections to lives lived 250 years ago in a world both strange and familiar. What strikes me most, thinking about 18th century English literature as a whole, is its fundamentally social nature, the way it emerged from conversation, from coffee houses and salons, from letters exchanged between friends, from periodicals that appeared like clockwork, creating rhythms of expectation and response. Literature was not yet the solitary art of the isolated genius. It was collaborative, argumentative, part of the fabric of daily life. Writers knew each other, read each other, responded to each other. Pope satirized his enemies in verse, and they satirized him back. Richardson and Fielding created rival versions of the novel, each defining his approach against the others. Johnson gathered a circle of friends who met regularly to talk, to argue, to test ideas in the crucible of conversation. Wollstonecraft wrote her Vindication in response to Burke, who was responding to events in France. It was all connected, all part of an ongoing dialogue about what literature was, what it should do, who it was for. And this dialogue was increasingly conducted in prose. The 18th century was the age when prose came into its own, when it proved itself capable of everything verse could do and more, capable of representing consciousness, of following thought in all its meanderings, of capturing speech, of building large structures that could contain multitudes. The novel was prose's great achievement, but so were the essay, the biography, the history, the philosophical treatise, all finding their modern forms in this period. The language itself was settling, becoming recognizably modern English. Samuel Johnson's dictionary helped with this, but so did the sheer volume of print, the circulation of texts, the standardization that came from commercial publication. By the end of the century, spelling and grammar had largely stabilized. The wild variations of earlier periods were disappearing, and yet the language remained flexible, capable of new coinages, new uses, responsive to the needs of those who wrote it. What the writers of the 18th century understood, what they passed down to those who came after, was that literature matters, not as ornament or entertainment only, but as a way of knowing, a way of exploring what it means to be human, to live in society, to face moral choices, to experience joy and suffering, to imagine other lives, other possibilities. They wrote for readers they imagined as their equals, as rational beings capable of judgment, of feeling, of thought. They did not condescend. Even when they instructed, they assumed intelligence, curiosity, a willingness to engage, and in doing so, they helped create the readers they addressed, taught people how to read critically, how to think about character and motive, how to recognize irony and satire, how to enter into fictional worlds and return enriched. The legacy is everywhere, in the novel as we know it, in literary criticism, in the essay, in the idea of literature as a profession, as something one could do for a living rather than as a gentleman's pastime, in the expansion of who gets to write, who gets to read, who gets to participate in the literary culture. The 18th century did not complete any of these democratizations. Far from it, but it began them, opened doors that would prove difficult to close, and it left us specific treasures. Richardson's deep dive into consciousness, Fielding's generous comic vision, Johnson's moral seriousness, Sterne's playful experiments, Burney's social observation, the Gothic imagination of Walpole and Radcliffe, Pope's perfect couplets, Gray's melancholy, Cowper's nature, poetry, Blake's visions, all of it still readable, still alive, still capable of moving and surprising and delighting us. Sometimes I think about the candlelit rooms where these books were first read, the effort it took to read by such dim light, the cost of books and candles both, the way reading was often a communal activity, one person reading aloud while others listened and sewed or worked. And I think about how desperately people wanted stories, wanted ideas, wanted windows into other worlds, enough to strain their eyes, to save their pennies, to argue and debate and fall in love with fictional characters, to let literature matter in their lives. We are their inheritors, we who read so easily, with light at the flip of a switch, with books cheap and abundant, with literature available at a touch. We have what they helped build, the novel as a form, the essay, the critical vocabulary, the assumption that literature is important, that it deserves attention, that it can change how we see and think and feel. The 18th century in English literature, it was a beginning, the start of modernity in letters, and it was an achievement in itself, complete, whole, worthy of attention, not just as prelude to what came after, but for what it was, for the writers who lived then, who worked with the materials and possibilities available to them, who created works of beauty and power and insight, who spoke to their moment and beyond it. The light grows softer now, the candle burns lower. And I find myself thinking not of grand conclusions, but of small moments, a reader turning a page, a writer dipping a quill in ink, the scratch of pen on paper, the slow accumulation of words into sentences, sentences into paragraphs, paragraphs into works that would outlast their creators, that would speak across centuries. There is something deeply moving about this, the way literature defeats time. Not perfectly, not completely, much is lost, most writers forgotten, most books unread, but something persists, a conversation that continues, voices calling to each other across the years, asking the same questions, exploring the same mysteries of what it means to be alive, to be human, to make meaning in a world that offers none, inherently, that requires us to create it through art, through story, through the careful arrangement of words on a page. The 18th century understood this. Its writers worked knowing that literature was how we make sense, how we share experience, how we reach across the gulfs that separate individual consciousness, how we build something communal, something shared, a culture, a tradition, a legacy. And so the books remain, waiting on their shelves, patient as only books can be, ready for the next reader, the next encounter, the next moment when someone opens a cover and enters a world that existed before they were born and will exist after they are gone, that eternal present tense of reading, where Richardson's Clarissa still writes her letters, where Fielding's Tom Jones still journeys toward his fortune, where Sterne's Tristram still tries to tell his story, where all of it lives again, renewed, made fresh, given breath by attention. I think of the comfort this offers, the continuity, the sense of connection to those who came before, who faced their own difficulties, their own uncertainties, who lived through war and revolution, plague and fire, personal loss and disappointment, and who made literature anyway, who believed in its value, its necessity, who gave their lives to it, who left us these gifts, these windows, these voices speaking still. The room grows darker, the words on the page harder to see, but they are there, waiting, as they have waited, as they will wait, for the light to return, for the reader to arrive, for the conversation to continue. And perhaps this is enough to know that literature endures, that the effort of attention is rewarded, that in reading we join something larger than ourselves, a community of readers and writers, us stretching back through time, linked by curiosity, by love of language, by the desire to understand and be understood. The 18th century gave us this, among so much else. This is sense of literature as connection, as conversation, as light against the darkness, as company in solitude, as proof that human consciousness, for all its isolation, can reach out, can touch, can communicate across all the barriers that divide us. The candle flickers, nearly spent, the wax pooling, the flame growing smaller, and soon there will be only darkness and quiet and the memory of words, of stories, of all that has been said and written and passed down, fading now, fading into silence, into the long, peaceful darkness where all stories end and begin again with the turning of a page, the lighting of a candle, the opening of a book, somewhere, sometime, by someone who wants to know, who wants to hear, who listens.